Good evening, good evening, everybody. Good evening, Black Mystery. Good evening, Dubai. Good evening, Ekaf. Hello, and all you friends right there who have been watching us at PWJ English YouTube channel. I welcome everybody. All the very best for your afternoon. I mean, actually, we have a habit of coming in the evening, and it is 4 p.m. So obviously, afternoon, evening, Giga, Chad, okay, Mr. Tango, Black Mystery, good evening, Purvi, hello beta, Vinod, good evening. Now, all of those, good evening beta, welcome, and all. I hope you must be grilling yourself in whole of the 24 hours because this is the actual peak time where you should be practicing to your maximum efficiency. This is Purvi. Hope you remember beta. Yes, obviously. I mean, all the people which who I received the comments from over here, you are very dear to us because you are the reason which motivates us and help us to navigate through all this process. Although with whatever viewership, but if at all we can help you, so knowing and remembering you is the only thing that we do. So definitely beta, and I hope that you also remember all these content that we are discussing over here. Now today, what is our job? Yeah, Arpan, good evening beta. Now guys, friends, what is our job today? Our job today is to revise through 50 questions. वैसे सच बताऊं, I have taken 52 questions because हाँ मतलब we I have taken the whole, I guess I was working at night at around till 2:33 to select at least those questions which will help me to allow to make you revise the concepts, because we with these 50 questions I am saying I'm not asking you to learn the answers, but yes, I am asking you to learn the concept because these concepts are going to be coming in your paper. Sir, admit card, which date? Arpan beta, it will be released. I mean, within a day or within a day or two. So don't worry, that is a job, the NTA's job. They'll definitely do that job. You have given the fee of your form now, so don't worry. They'll be doing that thing, and notification will be coming out any day. But by today, yes. See, whenever we say no by today, it definitely happens in the next day. And tomorrow is 29, so we have something huge coming at YouTube, PW YouTube channel also. So JEE, PW English medium YouTube channels, we are coming with huge announcement tomorrow. So yes, but you should definitely invest and devote yourself for your mains examination. But yes, we are also, I mean, you should also recommend to maybe some of your friends, your juniors. By the way, that promotional thing is not our priority. Our priority is to do these 50 questions. Those of you who have been coming to the sessions regularly, it will be a healthy revision for you. And those of you who are listening it for the first time, then please do this once in the live session, and after that I highly recommend to have a revision from the live section of PWJ English channel. The questions will be delivered to you free of cost. You just have to go to the PWJ English WhatsApp channel. You will be getting the complete lecture notes, and if you are listening it for the first time, then at least have a revision beta. Have a revision as in with a 2x speed. Again, see the recording and do these questions. From where to find these questions from? At PWJ English WhatsApp channel. So without further ado, with your pen and paper, Black Mystery, Arpan, Purvi, and Vinod, Kiran, let us start with the first question. We'll be covering the complete chemistry right from mole concept till class 12th inorganic and organic chemistry. So starting with mole concept, the priority you should know about mole concept is the basic three golden formulas. Number of moles is equal to given weight in gram upon molar mass, given number of molecules upon Avogadro number, and volume occupied by gas. The species has to be gas, and the gas has to be present at STP upon molar volume at STP is 22.4. So attempt, I need answer. I need answer beta. Start, take out your pen and copy, and I want you to attempt with me, because whatever the concepts will be discussing, the same concept you will be getting in your JEE paper. Trust me on this. I want everybody to come back after giving the paper and comment in this video. You will be coming by yourself. I do not have I have to ask you. Just finish this one lecture with me, the complete lecture. Give your JEE paper. Yes, and then you'll definitely come to this video and you'll say, sir, 17 सवाल, 18 सवाल, 20 सवाल इसी से थे. The concept, I'm not saying the same concept, but yes, I'm not saying the same question, but concept will be same. So I hope many of you have attempted this. I do not find answer from any student, but okay, let me help. Let me also attempt this with you. The question says that column 1 is having some given species in terms of number, weight and volume, and you have to compare with the number of moles. But number of moles of what? Number of moles of the oxygen atom. Okay. First one is giving us number of formula units, as in the molecule having this formula. I'm having this much of number of molecules. So this is value of N. So what shall be the number of moles? Given number, which is 6 into 10 raised power 24 upon Avogadro's number, which is 6 into 10 raised power 23. So number of moles is 10. If I would be having 1 mole of this molecule, how many oxygen atoms I'll be having? 4 into 3, 12, plus 3 into 1, 3. That means one molecule will have 12 plus 3, 15 oxygen atoms. So 1 mole molecule will have 1 mole, 1 into 15. One molecule has 15 oxygen atoms. So 1 mole will have 15 mole and 10 moles will have 15 into 10 as in 150 moles. So 150 moles as in 1 is S. Definitely. Yeah, perfect, black mystery. 90 gram of glucose. Now here also I have to calculate number of moles. What formula I'll use? Weight of substance in gram upon molar mass. So 60, and glucose has a molar mass of 180. Those who do not know shall definitely calculate. So this is half moles. So 1 mole will have 6 oxygen atoms. So half will have 3 moles of oxygen atom. So 3 moles of oxygen atom as in Q. So 1 is S, 2 is Q, and definitely by solving 2 I have my answer. But because we are practicing, so learning everything, 112 liter of gas at STP. So number of moles will be equal to volume occupied by gas at STP upon 22.4. This is 1 upon 2. That means 10 upon 2 as in 5 moles. So I'm having 5 moles of this. One molecule has 3 moles, so 5 will have 15. That means this is P, and this is again given weight upon molar mass. You just have to calculate molar mass of N2O5. You'll directly get number of moles, and if you calculate number of moles, number of oxygen atom will be 2.5. We already have 3 people answering. So moving to the next question. Vinod, Kiran, perfect beta. Perfect. Everybody is correct. Moving to the next question, I need answer. The question says, now such type of question, although this is mole concept only, but this mole concept is also having a relationship with practical organic chemistry. The general organic chemistry, later part of general organic chemistry also discusses about the quantification of the percentage of element present in an organic compound. This also uses the basic principle of mole concept. Therefore I have included these questions with mole concept, a very probable question. So I need answer for this too, beta. Sir, 90 gram tha. हाँ, 90 gram tha. So glucose 90 gram tha. So 90 is weight of glucose upon molecular mass of glucose is 180. Okay, you are saying 90 gram tha. So okay, I'm sorry. The 90 upon 180. हाँ beta, I am sorry, 9 2 ja 18. Yeah, perfect. 90 upon 180. Yes, this is 1 by 2. I'm sorry. 90 upon 180. So obviously answer is coming out to be same. Yeah, thank you. So everybody got that answer. Okay, we are having answer for this question also. Vinod is also showing 25%. Let us attempt this one now. The question says, in Carius method, during estimation of halogen, 3.2 gram of an organic compound gave this much of AgBr. Now, if your organic compound is having bromine, whatever treatment I'm doing with it, let's say the organic behind it says that if I dissolve this organic compound in a silver nitrate solution, then all the bromine present in the organic compound is extracted in form of AgBr. So first you have to calculate that in 1 mole of AgBr, 1 mole of AgBr as in what is the molecular mass of AgBr? Silver is 108, bromine is 180. That means if I have 188 gram of AgBr, how much bromine I'll be having? I'll be having 80 gram of bromine. So rather, if I have 1 gram of AgBr PPT, what is the weight of bromine, sir? 80 upon 188. You tell me, as per question, how much PPT of AgBr we are getting, sir? 1.88. So that means how much bromine will be having? This into 1.88. This is the weight of bromine that we are having, which is coming actually from the organic compound. So we ultimately know the weight of bromine. What are we asked in the question? We are asked the percentage of bromine, but in this organic compound. The weight of organic compound is given out to be 3.2 gram. So what shall be the percentage of bromine in this organic compounds? Are definitely weight of bromine upon this 3.2, which is weight of the complete organic compound, into 100. And yes, most of you have definitely done the multiplication, which is not easy. I want those of you who are attempting right now, very good. But those of you who are just reading it for the first time, attempt these questions just after the class. Do the into divide by yourself also. Your answer will be 25%. It will help you to practice also. It will help you to reattempt the question also. Moving to the next question. Perfect, guys. I'm very happy everybody's participating and giving correct answers. Moving to the next question now. Again, I would rather say this question also belongs to mole concept, but again, it has a friendship with that chapter of practical organic chemistry. The question says you again have some weight of organic compound. How much? 0.5 gram. You also, people, start attempting yourself. For those who are listening it for the first time and want to know the concept, I'm discussing and I'm solving with you. But those of you who feel that you should attempt by yourself, take out your pen and copy. First attempt by yourself. Let me speak. You can obviously listen to me again in the recorded version, but you also attempt with me. I hope I'm making sense. Those of you who are listening it for the first time and want to know the concept also, they can obviously look at me to solve the question, but actually your solving question is more important than watching me to solve the question. Now, 0.5 gram of organic compound was treated with Jaldal method. Now, Jaldal method is the process of estimating the percentage of nitrogen in an organic compound. So how does the Jaldal process works? Yeah, perfect. We have an answer. We know this saying 42. Let us check. So this much of organic compound, when subjected to Jaldal method, it releases nitrogen in form of ammonia. Now, as soon as the nitrogen in form of ammonia is evolved, it is absorbed by excess of sulfuric acid. The question is saying how much excess of sulfuric acid I'm using? This much. But because I'm using excess of sulfuric acid, so some of the sulfuric acid will be neutralizing ammonia and some will be left behind. So how much acid will be left behind? It can be quantified by the amount of base that we use to neutralize the excess acid. So how much base we are using? This much base we are using. So can you tell me number of gram equivalent of H2SO4 consumed? Yes. How much I have taken initially minus how much base is utilized to kill the excess acid. So how much amount I have used initially? Sir, in order to calculate number of gram equivalent, do molarity into volume into valency factor, because molarity is given. So molarity, which is 1/2 as in 0.5, into volume, which is 50 ml. So I'm calculating milligram equivalent, into valency factor of H2SO4 is 2, minus how much base I'm using to neutralize the excess acid, molarity, which is 1/2, volume, which is 80, into for NaOH, valency factor is 1 because it gives only 1 OH. That means this is nothing but 50 minus 40. That means 10 milligram equivalent. So that is the number of milligram equivalent of H2SO4 used, and how much H2SO4 we have required will be the number of gram equivalent of ammonia released. But we are not interested in the number of gram equivalent, rather we are interested in the weight of ammonia. So what we shall also write, that this will also be equal to number of gram equivalent of ammonia released, because number of gram equivalent allow us to be sure that we do not have to write the balanced reaction, because number of moles may be equal, may not be equal, how they can be related by completely balancing the reaction. But this is the profit of law of equivalence, because that number of gram equivalents are always equal. So what shall be the number of, what formula I should use for number of gram equivalent of ammonia? Weight upon equivalent weight. Why? Because we have to determine the weight of nitrogen in organic compound. So for number of gram equivalent, what I'm using? Weight of ammonia upon equivalent weight. Now equivalent weight is molecular weight upon valency factor. So molecular weight of ammonia is 17 and its valency factor is 1, because ammonia forms a base which is NH4OH, and how many OH minus and NH4OH gives 1. So its valency factor is simply 1. Now because I've taken number of gram equivalent over here, so that's why I'm also again writing number of gram equivalent over here also. This, because this is milligram equivalent, so what is milli? 10 to the power minus 3. So 10 into 10 raised to the power minus 3, this will be gram equivalent. So I can easily calculate weight of ammonia. So what shall be weight of ammonia, guys? This is simply 17 into 10 raised to the power minus 3, as in 0.12 gram. Now this is weight of ammonia, but what I am interested in, so we are interested in, let me borrow a new page. So actually over here we are interested in weight of nitrogen. So if I had 17 gram of ammonia, how much nitrogen I would be having? 14 gram of nitrogen. So 1 gram of ammonia will be having 14 upon 17 gram of nitrogen. And how much ammonia actually we are obtaining? 0.17. So what shall be the weight of nitrogen, sir, into 0.17? That means 0.14 gram of nitrogen I'm having. So this becomes weight of nitrogen. Now in order to calculate percentage of nitrogen in organic compound, weight of nitrogen upon weight of organic compound, which is 0.5, upon weight of organic compound into 100. Now this is the last into divide you have to do, which is 0.14 upon 0.5 into 100, which clearly most of you are doing this. This is somewhere around 28%. So okay, some people were replying 42. Vinod, no beta. Yeah. So I'm discussing concept also, and yes, I'm discussing obviously question also. So for those who know the concept, solve the question beforehand and then listen to it. That it will also give you a revision also. And for those who are listening it for the first time, obviously I'm helping you with the concept as well. Moving to the next question. The next question is again, now I am discussing all the important logics beta. So we are trying to cover the theory but with effective questions. So the next question is again a hybrid, because this is what January attempt was doing. It is making hybrid questions, not using one chapter but taking 2-3 chapters together, and this is what making the questions lengthier. So practicing the questions and again attempting these questions will definitely help you to recollect all the concept in your final D day. So attempt with me, guys. I need answer. So my beta Vinod, calculation mistake hota hai. Don't worry, but yes, after doing the questions during the analysis, just rectify that where is the, there is a pattern of attempting wrong or miscalculating things. So just identify your pattern where you fall of those calculation errors. So but yes, in order to analyze that where you are having those calculation mistakes, you have to discover a pattern in your problem solving method. So after the class, please analyze where you make common mistake of calculation error. So once you identify that, during the examination, pause, maybe give 5-6 seconds more in that calculation part, so that you at least if you are solving a question, the answer that you are getting is correct, because otherwise it will create a -5 mark difference in your overall marks. So that silly mistake is huge sometimes. Chalo beta, answer. Okay, Kiran is saying 2. Let us check beta. Now the question says, let me now discuss the basic behind it. The question says ammonium nitrate gets converted to nitrate, and ammonium as in NH4 plus is converting to NO3 minus. So let us find the valency factor first. Here nitrogen is in X plus 4 equals plus 1, as in nitrogen is a -3 state, and here it is clear that X minus 6 equals -1, that it is plus 5. So from -3 to plus 5, how many electrons are getting transacted? 8. -3 to plus 5 is nothing but oxidation. The other part, which is phosphate, PO4 3 minus, is converting from phosphate to phosphine, PH3. So let us identify the oxidation state. X minus 8 equals -3, as in phosphorus is in plus 5 state, and here phosphorus is in -3 state. So transaction is again 5 to 3, so 8 electrons, but it is not oxidation beta, it is reduction. That means in this salt, ammonia is getting oxidized and phosphate is getting reduced. I hope you are getting this. Now this salt is reacting with whom? With KMnO4 in acidic medium. For KMnO4 in acidic medium, everybody should know that it is an oxidizing agent, and oxidizes others and reduces itself. Reduces itself to what? From MnO4 minus, it rather forms Mn plus 2, because it is happening in acidic medium. Basic medium, it forms, if it is mild basic, it forms MnO2, and if it is strongly basic, it forms MnO4 2 minus. But that is not asked in the question, it is just asking the acidic medium. In acidic medium, its valency factor is 5. Everybody knows this. Now again, I do not have to write the complete balanced reaction, I just have to do the stoichiometry, and in order to do the stoichiometry, I'll do law of equivalence, which is number of gram equivalent of salt, number of gram equivalent of salt will be equal to number of gram equivalent of the oxidizing agent. Now sir, but how can we calculate valency factor? I'll tell you. See, this one's, what is valency factor? What is the electron transacted by one species, one molecule of the salt. Now this salt is having ammonium ion. How many ammonium ion? Sir, 3 ammonium ions. So those 3 ammonium ions are doing what? Sir, they are getting oxidized. Oxidized as in from this to this. How much electron one ammonia is using? 8. So how much electron 3 will be using? 3 into 8. But sir, they are getting oxidized. So in order to oxidize, they will want to give electron. So they are giving electron. But the 8 into 3, which is 24 electrons, they are giving, because they are getting oxidized. Who is taking those extra electrons? Sir, MnO4 minus, but one more species taking. Who? Phosphate. So subtract the number of electrons, because ultimately this one molecule is having 3 ammonium ion. One ammonium ion is giving 8 electrons. So 3 will be giving 8 into 3, as in 8 3 are 24 electrons. But as a species, the salt, which part of the salt? The anionic part of the salt is also consuming. How much that component is consuming? Sir, if 3 cations are coming, then 1 anion will also be coming, and that 1 anion will be asking for 8 electrons. So subtract those 8 electrons. So for one molecule of salt, what is the number of electrons it is giving? This minus this. And now whatever effectively one molecule of salt is giving will be the valency factor for the effective salt getting oxidized, because ultimately this is the oxidizing agent. one molecule will come, it will reduce itself and it will oxidize the counterpart. So I hope everybody is getting this, that this is how we calculate valency factor for the salt. Now for the salt, what is given? Sir, for the salt, its molarity and volume is given. Valency factor we have already calculated. So again, applying law of equivalence, so molarity, which is 0.2, volume in ml is 50, into its valency factor effectively is 24 minus 8 as in 16. Now this is the effective valency factor. And what about, sir, KMnO4? Just check what is given for KMnO4. Sir, volume into, okay, its normality is asked. So we do not have to use valency factor for KMnO4. Why? Because for KMnO4, molarity is not asked, normality is asked. And number of gram equivalent is equal to normality into volume. Volume is 16. So we do not have to use this 5 also, because for in the question only normality is asked. So the calculation is also easy. 16 gone. So normality is 50 into 0.2 as in 10. So answer is beautifully 10. I hope, yeah, perfect. Good question. But deliberately I have taken this question because NTA is also doing this. NTA is also playing with our common sense when discussing the questions of mole and redox. So either don't attempt it. Obviously, if I will be having such question in my mains paper, I'll not be attempting this question in the first go. I'll be doing the easier question first, and then after doing all the easier questions of physics, chemistry, maths, if at all I'm coming back to chemistry, in the second attempt I'll be discussing such questions. Now I hope everybody is clear with this. Sir, why didn't you add the phosphate and ammonia ions? Beta, I didn't add because in the salt, one cation is getting oxidized. The cationic part is getting oxidized. Cationic part is oxidized, but anionic part is reduced, beta. +5 to -3 is reduction. That means it is phosphate ion is gaining electron and ammonium ion is getting oxidized. And what is the job of KMnO4? It is always an oxidizing agent. So this being an oxidizing agent will oxidize other. In order to oxidize, they have to give electron. So how many electrons one salt is giving? Ultimately it was giving 24, but those 24 electrons are not reaching KMnO4. How many it is reaching? Sir, out of the 24, 8 the anionic part is eating, but at least 16 KMnO4 is getting. So in the electronic transaction between KMnO4 is getting 16 electrons from one salt, because its cationic and anionic part are not doing the same job as per oxidation and reduction. I hope you are getting what the logic is. So yes, general trend of calculating valency factor you obviously know. Add for the, but if I would be adding for the cation, then both the cationic and anionic part would be getting oxidized, because one part is getting oxidized and other part is getting reduced. That's why I have to subtract the number of electrons which is itself the salt is requiring in itself. So out of the 24 electrons, 8 electrons are not coming out of the family. 8 electrons is consumed within the family. So ultimately this one salt is giving how many electrons? 16. I hope everybody, a good question, but I hope everybody got the logic. So black mystery is asking relationship between molarity and normality. Black mystery, learn it, very easy. Normality is nothing but molarity into valency factor. What is valency factor? For an acid, number of H plus. For a base, number of OH minus. For a normal salt not doing redox, total cationic or anionic charge. And for a salt which is doing redox, then you have to calculate the valency factor, whatever one species undergoing whatever number of electronic transactions. I hope it is clear. Yes, perfect. So we have invested sufficient amount of time in this question. No worries, because this finishes the golden 3 chapters: mole, redox. Because with those chapters, if you're comfortable with such basics, it is more than sufficient. Now, moving to atomic structure. Now I am just going to give you the basic formula, and we'll just practice few questions. Learn all the formula for from Bohr model. Radius of electron in nth orbit, Rn is equal to R naught into n square by z. I'm iterating everything for you. Velocity of electron in nth orbit is V naught into V naught into Z upon N. Z upon N. And energy is minus E naught into Z square upon N square. At least learn this much of formulas. What are the value of constants? A naught or R naught is equal to 0.529 angstrom, V naught is equal to 2.18 into 10 to the power 6 meter per second, and energy E naught is equal to minus 13.6 electron volt or 2.18 into 10 to the power minus 18 joule. This much formula you should learn in your tips. Now let us use those formula and solve some more good questions. So what else is asked regarding atomic structure? Like this question. The question says, if the radius of first Bohr orbit of hydrogen is a naught, let's say, so radius of first orbit is r naught into n square upon z, because hydrogen, so z is 1, first orbit, so n. So actually value of r naught is given out to be a naught. This is equation number 1. Now then the de Broglie wavelength of electron in third orbit. So let us first check what is de Broglie's equation. So lambda de Broglie is nothing but h upon mv, and through Bohr's second postulate we know angular momentum, which is mvr, is nothing but it is multiple of, which is n times of h upon 2 pi. Everybody knows that 2 pi into r is circumference of the circular orbit. So this 2 pi r is equal to what? It is equal to n times of h upon mv. H upon mv, and this h upon mv we have clearly seen it is equal to de Broglie wavelength. That means 2 pi r is nothing but n times of de Broglie's wavelength. Now this is the formula I want everybody to please remember. Now applying this formula, we have to do this for the third Bohr orbit. So for third Bohr orbit, radius will be r3. So using this formula, 2 pi into third Bohr orbit will be r naught, which is a naught, into n square, which is 3 square, upon z, which is 1 for hydrogen. This will be r3, will be equal to n times of wavelength. So for third orbit, n is 3, and this is my wavelength which is required in the question. So this is quite easy to calculate now. This is nothing but 6 pi a naught as an option 3. Everybody is clear? Yeah. Raina is perfect. Sohan Sarma 11th is wasted. Don't worry, Sohan. Be with me for the complete class and everything will be good for you. Be with me, just be with me, and after the class, if you are listening it for the first time, then do revision also with a 2x speed. Take these notes from PWJ English WhatsApp channel. Moving to the next question. I want everybody to attempt. Take out your pen and copy. Attempt with me. Take out your pen and copy. Yeah, set. Take out your pen and copy. Attempt with me. Now, the next question says the minimum uncertainty in de Broglie wavelength of an electron accelerated from rest by a potential difference of 6 volt. So let us, this is also a very beautiful formula. Mains ask it a lot of times. Sohan beta, I understood. Laksh beta, because you're obviously confident enough that you have wasted your 11th, then why you are asking this? You should definitely go for Laksh 1.0. Why wait for 2.0? The best and most effective way to start is start now, today. Whatever you have done, let it be. At least start fresh from today. So no more delays. Start from today. So let us first quantify the de Broglie's wavelength. Sir, we definitely know de Broglie wavelength is equal to h upon momentum mv, and obviously this momentum in terms of kinetic energy, this formula also you must remember from your physics, that it is equal to twice of mass into kinetic energy. Now, because we are exciting some charged particle, so what is the kinetic energy? Sir, potential is equal to work done, which is stored in the form of kinetic energy upon charge. So kinetic energy will be equal to charge into the potential with which the charged particle is accelerated. So de Broglie wavelength is equated like this for a charged particle which is accelerated by some potential. Now, at least for a mains level of question, because such questions are very very famous, yes, you can put the value and solve, because value of H is 6.626 into 10 to the power minus 34, 2 is 2. Mass of electron is 9.1 into 10 to the power minus 31 kg in SI system. Charge is 1.6 into 10 to the power minus 19 coulomb. We can definitely put all those value and calculate, but it will take time. So for an electron, a good student should learn this also, that by putting all the values of the constant, I get 150 in the numerator under the root upon the potential with which I accelerate. If I do this, my wavelength comes in terms of angstrom. So this is the formula which I want everybody to at least learn, because you are practicing. So practice some good quick formula which will also help you to save your time in the real examination. Now, if some of us know this formula, then directly we can calculate de Broglie's wavelength in angstrom. How? By using that formula, which is under root of 150 upon how much potential we are using, 6. So this is 25 as in 5 angstrom. But what is asked? We are asked uncertainty in measuring the position. Okay, uncertainty in measuring the position is given 1 upon pi angstrom. We are asked uncertainty in de Broglie wavelength. But sir, so this formula, I hope everybody remember. I am giving you this formula also, very important formula. So please beta, learn this now. But sir, we are not asked this. We are supposed to use Heisenberg uncertainty, which says uncertainty in position into uncertainty in momentum is either greater than, and what is the critical value? It must be equal to h upon 4 pi. So because we are doing calculation, so we are equating, but we definitely know theoretically that this multiplication will be greater than h upon 4 pi. Now, in order to calculate delta P, first let us do the common sense of de Broglie's. What is de Broglie telling us? De Broglie telling us that lambda is equal to h upon P. Or I can say momentum is equal to h upon lambda. Or I can say, if I differentiate momentum, because this is a average change, so let us find the fractional change. So dp will be equal to, let us differentiate lambda. So this is, h is a constant, so this is lambda raised to the power minus 1. So x raised to the power minus 1 is minus 1 upon x square, as in lambda square dot d lambda. So a fractional change is this much, so average change will be delta P. So delta P can be replaced by this, but sir, this is minus. What does delta tells you? Uncertainty. So it may increase also, it may decrease also. So because we are just measuring the uncertainty, so you should rather just be interested in the magnitude. So definitely I can say the magnitude of uncertainty in momentum will be equal to, I'm not considering this negative sign because it can increase also, it can decrease also, because this is uncertainty. So from the absolute value you can calculate more amount also, you can calculate less amount also. That's why I'm neglecting the negative sign. So it will be h upon lambda square. Instead of d lambda, I'm writing delta lambda. So this will be my uncertainty in estimating wavelength. So replacing this equation 1 with that conclusion, therefore I'm having uncertainty in position into h upon lambda square times uncertainty in wavelength is equal to h upon 4 pi. Now this is quite easy also and attemptable also for us, that constants are gone. This uncertainty is given us to be 1 upon pi angstrom. So this is 1 upon pi. So this pi and this pi is also gone. Lambda we have calculated 5. So lambda square will be 25. So uncertainty in wavelength will be 25 upon 4 in angstrom, as in 6.25. Perfect. So a good question, and that's what I'm telling you over here. I am not going to discuss more number of questions. With one question, I'm actually giving, I'm not saying that this was an easy question, but yes, in order to learn all the concepts which are probable for a JEE Mains level of question, you may get a question from this concept. Not all the concept will be used in one question, but I've deliberately taken such a question which will allow me to help you memorize all the concepts. I hope you're getting what I'm trying to say. Sohan beta, I already replied. See beta, people are having their paper after 5 days. यू आर आस्किंग मी कि सर मेरी 11th वेस्ट हो गई है, अब मुझे ये समझ में नहीं आ रहा कि 12वीं करूं कि लक्ष्य 1.0 करूं कि लक्ष्य 2.0 करूं. नाउ यू टेल मी, you are sure and confident that your 11th is wasted, beta. Now because your 11th is wasted, my friend, then obviously you are asking this, that means you are concerned about it. So beta, if you are concerned, where is the essence your concern is lied on upon? Sir, waste ho gaya hai. So in order to revive, what you have to do? Work now. So you are asking, sir abhi kaam karu ki 10 दिन बाद काम करूं? बेटा अभी काम कर. So starting with Laksh 1.0 is abhi kaam karna. Why waiting for maybe a month or so for Laksh 2.0? Start from now, because whatever time you have lost, why you are planning to lose some more, my friend? So I hope, Soham beta, you are clear what you should do from as per my suggestion. Perfect guys. So 6.25. Good question. A very logical question to revise atomic structure, most probable formulas. Moving to the next question. Now, the next question, I'm directly jumping to thermodynamics now. After atomic structure, directly, first we'll do the physical chemistry, then organic, and last part will be inorganic. So first we'll be doing whole of the physical chemistry questions. So directly moving to thermodynamics. Now from thermodynamics, I'm directly jumping to the previous year questions only, because thermodynamics, if you talk for an advanced type of question, you are supposed to study so many things. But for a mains mains level of question, if the question asked to you is not difficult from thermodynamics, then such type of concepts will only be asked. So I'm giving you all the most probable logics from thermodynamics, where the first logic is, the question says 500 joule of energy is transferred as heat to 0.5 mole of argon, which is a monoatomic gas, at this much temperature and this much pressure. So this is constant pressure and constant temperature. So because we are supplying heat at constant temperature, so heat exchange between system and surrounding at constant pressure changes what? Sir, changes its enthalpy. Very important conclusion. Similarly, heat exchange between system and surrounding at constant volume changes what? Sir, it changes its internal energy. So these are two very important conclusions. Heat exchange at constant pressure is delta H, heat exchange at constant volume is delta U. Now, what is the general idea of enthalpy change? Sir, enthalpy change of a system is equal to number of moles present in the system into heat capacity of the system at constant pressure into delta T. Similarly, number of moles into heat capacity at constant volume into delta T. Or a monoatomic gas, value of CV is equal to 3 by 2R. And Cp is equal to Cv plus R. That means Cp will be equal to 5 by 2. So first let us put this value, because heat is given at constant pressure. So this is 500 joule. Number of moles is 0.5. Cp for this monatomic gas will be 5 by 2R. R is 8.314, but in the question it is saying you take 8.3, so take 8.3 into delta T. So what will be delta T? Final temperature minus initial temperature is given out to be 298. Just solve this, you will get your final temperature, which I guess you will be coming around somewhere around 346, 347. So 348 will be your answer. After calculating final temperature, obviously we know what is the answer, but in the question, because this is a JEE 2025 question, in the question you were also asked to calculate the change in internal energy. After calculating delta T, we know delta T. CV is 3 by 2R. Number of moles is 5, so we can definitely calculate delta U also, but in your paper also you do not have to calculate it. Once you are calculating the temperature, there is only one option. So why waste our time? But why I'm telling everything? Because I want to revise the formula. So this is the first formula which everybody should know. Perfect. Moving to the next question. Again, a very beautiful concept from thermodynamics. So I want answer by the time I'm sipping some water. Sonali is back with us. Dear respected sir, my paper is a Sonali. My all the good wishes to you, beta. I know you will rock the paper. Best of luck, beta. Best. all the very best from my side. All the very, very best. हाँ बेटा, solve as many PYQs as you can. Sir is yes beta. Sonali, just start attempting PYQs, but in what fashion? January attempt first. After that, April 2025, January 2025, April 2024, January 2024 in a reverse fashion. Attempt as much as you can, but don't try to mug the questions. Try to mug the concept what is asked. So beta, you are saying that in general you were doing Vijay. Sorry, sir. I lost. Don't worry, beta. Don't worry, Sonali. Don't worry. The battle is still not lost. You are still in the game. What you have to do is whatever remaining amount of time you have to recollect your mindset. Just recollect your mindset, and everything will be good. Don't worry. You have not lost. And Vijay Nathan, Vijay Nand, Vijaya, Nand. Vidya, I'm sorry if I'm pronouncing your name not properly. So Vidyanand, beta, I'm advising you, if you feel that you have worked for the 2 months and just in the previous mock you have got less marks, so do not get disheartened. Yes, analyze the mock, that why you have not attempted questions or why you have not got marks. If the answer is you were missing some formulas, then revise those formulas. If the conclusion is the paper was difficult, then it will be difficult for everybody. So even if you have got less marks, so why bother? Everybody will get less marks if the paper is difficult. So getting lesser mark is no big deal. In the January attempt, students scoring somewhere around 80 to 88, 87 marks were getting 93 percentile. In a sorry, not 79 marks. Yes. I was doing that one shot yesterday, so I was analyzing that. A student scoring in an difficult version of chemistry session, if a student was scoring somewhere around 61 62 marks, then even with 61 62 marks the student was having 93 percentile in chemistry. So because if a paper is difficult for you, it will be difficult for others also. They will also be rushing and searching for the easier questions. So don't worry. Yes, analyze yourself properly. So analysis is most important key at this crucial point of time, beta. So please do that. Beta. Sonali, I already answered. Why you are saying that it is enough? I'm not saying you just have to do till 2024. If possible, why not more? So I'm not even, don't make that target. नहीं 2024 तक करना ही है. Go in a reverse fashion. And how much previous years possible you can attempt, but go in a decreasing fashion, as in first attempt the PYQs of January 2026, then April 2025, then January 2025, so on. Do not limit yourself कि नहीं 2024 तक ही करना, उसके पहले के क्यों नहीं करना if possible, है ना sir? 150 enough for, हाँ बेटा. Black mystery 150 in general speaking, yes, because what January attempt has shown us, definitely the paper is going to be difficult. So everybody will be facing that level of difficulty. So obviously the overall marks may differ, but yes, somewhere around 150 to 170 will fetch you somewhere around 95, 96 percentile. I mean, general idea. So start attempting the paper, beta. We'll be having this discussion a lot in the later, because this is not the time for estimating the output. This is the time for indulging in the input. So let us indulge in the input. I want answer. Nobody has given me answer. So 50 papers and 24 तक तो 7.5 days में इतना ही करना. I understand, Sonali. That's why I'm saying, Sonali, ना 2024 तक भी why you are keep making a pressure. Do till 2025 also. But if I'll say कि 2025, then you'll have a feeling कि कोई बात नहीं, समय ज़्यादा है. So maximize yourself, whatever maximum possible you can do that. But yes, with a पॉजिटिव फ्रेम ऑफ माइंड. इफ यू से नहीं नहीं 24 करना ही है तो 25 भी गंदे से होगा, इज व्हाट आई एम सेइंग. सो वट एवर यू आर डूइंग, इफ यू आर डूइंग इट विथ ऑल योर हार्ट्स, मे बी इट इज टेकिंग टाइम, लेट इट टेक टाइम. एटलीस्ट वट एवर यू आर डूइंग यू शुड डू वेरी परफेक्टली. आई होप सोनाली आई एम मेकिंग सेंस. हाँ चलो. सो किरण, आई एम सॉरी बिकॉज स्टूडेंट्स आर आस्किंग क्वेश्चंस, सो लेट अस डायरेक्टली जंप इनटू द क्वेश्चंस. हाँ बेटा. सो विच ऑफ द फॉलोइंग फिगर शोज एडियाबेटिक प्रोसेस? नाउ actually, if you compare adiabatic process with an isothermal process, the slope of a isothermal process is PV is equal to constant. Slope is dP by dV. So let us say P is equal to K into 1 upon V. So 1 upon V is again minus 1 upon V square dot dV. So dP by dV will be the slope of an isothermal process, which will be equal to nothing but K upon V is P. So this is minus P upon V dot dV. And this dV I've already taken over here, so I'm removing from this side. So actually this is the slope, which is nothing but 1 times of ratio P by V. And if we compare the slope of a adiabatic process, so slope of an adiabatic process is actually this dP by dV will be equal to gamma times of the ratio of P by V. So whose slope is more, sir, of a adiabatic process? That means if you change volume, the increment or decrement in pressure will be more for a adiabatic process. So this is the general idea mathematically, but for a mains level of question, I'm giving you trick also. What is the trick? This is expansion. So start from the initial point, put your thumb on the initial point and then do clockwise curling. Whatever you meet first is the isothermal process. So because I'm starting from here, moving clockwise, what I'm meeting first? This. So first is isothermal and second is adiabatic, because obviously the slope of adiabatic is more, so it should be lying down. Now, similarly, from where I'm starting here, curl your finger clockwise. Whatever we are meeting first, which is this, will be isothermal. Obviously, the later one will be adiabatic, because obviously slope is more for adiabatic. I hope with every sense you're making this clear in your mind, but yes, for a paper it will be much easier concept for you. So out of them, which is adiabatic 2, out of them, which is adiabatic 3, so 2 and 3, option 1. I hope everybody is with me. No, Kavyak, option 2. Kiran, I hope everybody is clear. Ha, acha, you are saying 2, 3. Ha beta, 2, 3 as an option 1. Perfect, black mystery. Moving to the next question. I hope everybody is clear with this. Perfect. Moving to the next question, beta. The next question says, an ideal gas undergoes isothermal compression from this to this. So this is V1, this is V2. We can clearly see it is compression, but if you are just going by your basic formula, so don't bother about expansion or compression. Just okay beta, superb thumb rule. Okay, perfect. Now an ideal gas undergoing isothermal compression from this volume to this volume against constant external pressure. Now because external pressure is constant, that means process is irreversible. If it is variable, then it is reversible process. So what for an irreversible process, what is the formula of work? Sir, work irreversible is equal to minus external pressure, which is obviously the final pressure, into change in volume. So minus 4 into what is dV? Final is 1 minus 5. So this is nothing but minus 16, because this is Newton per meter square, this is meter cube. So this is SI unit, and what is SI unit of work? It is nothing but joule. So simply joule. Obviously, because it is compression, that means we are working on the system. So if we work on the system, we are giving the system some heat. But sir, if you are giving system some heat, the temperature of the system will rise, but it is telling us that it is isothermal. Sir, if you are working on a system, then you must be giving it energy, and by giving it energy, its temperature should rise. Why its temperature is not? Yes, definitely this minus will become plus. So this is plus 16 joules. So I am giving this much of heat to the system in form of work. Why the temperature of the system is not rising? That means as soon as I'm supplying this quantity of heat to the system, it is throwing all the work in form of heat. And this heat we are utilizing to do some work. What is the work we are doing? The heat released, the work that we have done, 16 joule, that 16 joule is thrown in the form of heat. And this heat is used in the process to increase the temperature of 1 mole of aluminium. So this heat we are using to rise the temperature of 1 mole of aluminium. So this 16 joule which we have worked upon on the system is released in the form of heat and given to aluminium. What aluminium? 1 mole of aluminium, whose heat capacity is given. Now we are asked that the temperature of aluminium is increased by. That means it is again, what is the amount of heat we are giving to this aluminium? Sir, 16. What is heat? Sir, heat is number of moles into heat capacity into delta T. This is the total heat we are giving to the system. So 16 is equal to how many moles of aluminum I'm having? 1. What is its heat capacity? So 24. You can directly find the value of delta T, which is nothing but 2 by 3. So a very good question. Not very typical one, but very logical question. And this is, I have not taken this question from any reference. This is a JEE Mains 2019 question. So I hope everybody is clear. Yeah, Rana is perfect. Kartike is perfect. It's student. Hello, beta. Perfect. Kartike, perfect. Moving to the next question. Again, 2025. So a beautiful question requiring a trick also. Although it is not a trick, it is a common sense. I am telling you the common sense first. If you try to calculate enthalpy change or enthalpy of any reaction, what are the basic two formulas? Sir, enthalpy of formation of product minus enthalpy of formation of reactant. I hope everybody knows that formula. Enthalpy of reaction is also equal to bond enthalpy of reactant minus product, the second formula. I am giving you one more formula, because that formula NTA is asking so many number of times. That is also statistical conclusion, but it will save your time like anything. If you are given enthalpy of combustion, then in terms of enthalpy of combustion, you can also find enthalpy change of a reaction. How? By summing the enthalpy change of combustion of reactants minus enthalpy change of combustion of product. Here I am not talking of bond enthalpy or enthalpy of formation. I am talking of their enthalpy of combustion. I hope I'm making sense with this. Please learn this formula and let me tell you how this statistical conclusion will help you to solve questions quickly. Now you will find number of questions. I'm just giving you one question for an example to help you digest this formula. Now here we are given 3 reactions and we are asked to calculate the magnitude of, we are not bothered with the sign, the magnitude of enthalpy of formation of C2H6. But sir, you are telling us we can calculate enthalpy of reaction. It is asking enthalpy of formation. So enthalpy of formation is also enthalpy of reaction when 1 mole of compound, which is C2H6. So when 1 mole of C2H6 is produced from its constituent elements, which is carbon and hydrogen in their most stable state, which is carbon solid and hydrogen gas. Because I need 1 mole of this, so I need 2 carbon solid. I need 6 of hydrogen, so I need 3 moles of hydrogen gas. So enthalpy of this reaction is nothing but enthalpy of formation. So enthalpy of this reaction is nothing but enthalpy of combustion of reactants minus product. What are the reactants? Carbon solid. Combustion, not formation. Combustion. Carbon combustion, sir. Carbon solid is carbon graphite and it is its most stable state. So carbon graphite getting oxidized, sir, if you take 1 mole of a solid and undergo its reaction with oxygen, this is nothing but enthalpy of combustion of carbon graphite. So which is given out to be minus 393.5. So how much carbon I'm using over here? 2 moles. So this is 2 into minus 393.5. This is reactant 1 plus, what about reactant 2? Hydrogen. 1 mole of hydrogen gas is getting oxidized. That means this is also combustion. So how much energy is released? Minus 286. How many moles of hydrogen I require? So 3. So into 3. So this becomes summation of enthalpy of combustion of reactants minus summation of enthalpy of combustion of product, which is C2H6. So do I have combustion of 1 mole of C2H6? Yes. How much energy is released? Sir, 1550. So 1550, but how many moles I'm supposed to get? Only 1. So into 1. So this becomes enthalpy of combustion of product. Just do plus minus whatever value you have. Don't think about the sign, because in the question you are just asked the magnitude. Once you solve it, you will get, I'm saving my time, your time also, because into divide will be your job. That will help you to practice also. That will help you to, yeah, black mystery. Perfect, 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 perfect. हाँ, organic physical mixed concept. Beta, it's student. I have taken 50 questions. I'll be discussing complete chemistry. Complete chemistry, 50 questions, which will help me to make you revise complete logical chemistry. Logical as in most probable questions that JEE can offer you with whole of physical, organic and inorganic. Moving to the next question now. Yes. In organic chemistry, I have taken such questions that discussing one question will help me revise so many concepts. So don't worry. Yes, number of questions of physical I have taken more deliberately because people fear physical chemistry more. Organic and inorganic, the questions which I have taken will help you. I have taken such questions which will help you to revise most of the probable concepts. So don't worry. Sit back. Give me your time till 7 p.m. We'll be done. Don't worry, we'll be finishing before 7 only. So this is 5. I'll be requiring 2 more hours, less than 2 hours, and we'll be discussing and completing all the 50 probable logics. More than 50 actually. Moving to the next question, which says total enthalpy change for freezing of 1 mole of water at 10 degrees Celsius to ice at minus 10 degrees Celsius. So first of all, I'm having 1 mole of water liquid. This I am converting from 10 degrees Celsius till 1 mole of liquid water at 0 degrees Celsius. That means I have to extract heat from this water. If I extract more heat, this H2O liquid will become H2O solid. Temperature will still be 0 degrees Celsius because this will be phase transformation. So this will be nothing but enthalpy of fusion, because temperature will not further decrease till all the liquid is converted to solid. And after that, if we extract more heat, it will turn into H2O solid. But now temperature will fall from 0 degree. I want to bring it to minus 10 degree. Obviously, I know that we have to withdraw heat in order to make the system cold. So let's say the magnitude of heat I'm extracting is Q1 in this process, Q2 in this process, and Q3 in this process. Let us check what is given. Enthalpy of fusion, which is this process, is directly given out to be x kilojoule, because everything is in joule and this is kilojoule. So for 1 mole, how much heat you have to withdraw? X kilojoule. So withdraw as in minus, because heat taken out of the system. X kilojoule for 1 mole as in 1000 x joule for 1 mole. So I hope Q2 is nothing but 1000x minus 1000x. What about Q1? So for the liquid water, heat capacity is Y. So for 1 mole, how much amount of heat I have to withdraw? Y joule. So Y joule withdrawing, so minus Y joule. But so this is the heat capacity of 1 mole. What is the temperature change? That will also take into account. Why, sir? Because heat is equal to number of moles into heat capacity into delta T. This will be the total heat. So because I have to calculate this total heat, so this will be equal to number of moles into heat capacity is Y into delta T is 10 to 0 is 10. Change is 10. And because I'm taking out this heat, so whatever magnitude you're having over here, it will be coming with a negative sign. So this is nothing but minus 10y. I hope everybody is clear with this. So this is nothing but minus 10y. Similarly, this will be nothing but minus 10z. See, this is z. I hope everybody is clear with this now. So what is the total amount of heat we are taking out of the system? So this plus this with sign. So total is minus 10y minus 1000x minus 10z. Taking minus 10 is common. So it is 100x plus y plus z. Perfect. 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 Venkat. Perfect. Let me check this answer also for you. Beta, it is 2. So we have not done any sign mistake. Perfect, guys. But yes, practice hard so that you are also very confident enough that whatever answer you have got is perfect for you. Moving to the next question. Again, a thermodynamic basics. So I have included these questions of thermodynamics because the area of thermodynamics is, I feel, the difference making area in your chemistry paper, because most of the students attempt that inorganic, organic, although I'll be discussing. But if one of the 99 percentiler is also watching this, then for that student such questions is very crucial. So I have deliberately made this 50 questions in such a way that I can cater to each and every type of student. Those who are aiming 95, it will be helpful for them also, but those who are aiming more than 99, it will be helpful for them also. Moving to the next question. Again, 2025 question which says the resonance energy of this. We definitely know resonance, delocalization of non-sigma electrons provides stability. So how to quantify that resonance energy? It is nothing but enthalpy of formation that you observe actual, because actually if a system is stable, it will not release that much of energy when it is formed, minus enthalpy of formation which you estimate by your basic calculation of thermodynamics. So actual or observed value minus calculated value through thermodynamic formulas that we know. For this system which is having a resonance stabilization, the question is giving us the enthalpy of formation of this X2Y, as in which is resonance stabilized. So for this X2Y, enthalpy of formation is this. So this is what value? Sir, this is the actual or experimental value, which is 80. When 1 mole of this is formed, actually how much energy is required? Sir, 80. But let us find that what is the calculated value. Sir, how to find the calculated value? We know this is enthalpy change of this reaction, so which is given us to be 80. Now, can you take this enthalpy of formation as enthalpy of reaction? Yes, sir. And enthalpy of reaction is also equal to bond enthalpy of reactant minus product. So what if you think of no resonance, how you will make X2Y? Sir, Y double bonded X. Simply, this is how you are going to make, because the bond energy of Y, X double bond Y is also mentioned, of X double bond Y. So this is also mentioned. So if we have no extra stability of resonance, then what shall we do with the bond enthalpies? We take that enthalpy of a reaction is equal to bond enthalpies of reactant minus bond enthalpies of product. This is what we do via our mathematical calculation. So this will rather give us bond enthalpy calculated. This 80 we have got actual, but if we calculate what value we'll be getting, that will give us enthalpy of formation, but it will be our calculated value. So let us find that calculated value. So let us quantify enthalpy of bond enthalpy of reactant. So reactant, I'm having 1 mole of X triple bond X. For X triple bond X, bond enthalpy is how much? 940. So 940 into 1 plus what is the another reactant? Y double bond Y, but half of. So Y double bond Y, first, second, third. First, second, third is 500. But 500 upon 2, because stoichiometrically it is 1 by 2. So 500 upon 2 is 250. This becomes bond enthalpy of reactant minus. What about product? So this is product X double bond Y, X double bond Y. So X double bond Y is how much? Acha. Okay, I'm sorry, beta. Because if you just go by the structure given, this, which is having no resonance, it is X double bond Y. I beg your pardon. You just have to see the resonating structures because bond enthalpy of other double bonds are also given. So X double bond X and X double bond Y is there in the product as per the data given. So X double bond X is how much? Sir, 410 plus. Next is given X double bond Y. Yeah, X double bond Y. This is how much? 602. So as per data given, you can either quantify that theoretically what you expect the bonds to be. So this value, if you calculate, will give you the enthalpy of formation calculated. So solve this value, put this value over here. Whatever answer you will be getting, don't take the negative sign, because in the question you are asked the magnitude of resonance energy. So I hope into divide each and everybody will be doing back at home, which will help you to revise also. Once you do it, you will be getting answer as 98 kilojoule per mole. Did any student solve this for me? Sir, from these questions, model, can we expect? Yes, beta, not 50 plus, more than that. Don't memorize the answer, beta, but yes, memorize the question, memorize the concept, and memorize the logic used, because this, I am telling you, is actually going to repeat in your paper, because whole of the paper cannot go beyond these concepts. These are all the logics that I have used. Yeah, perfect. Black mystery, perfect. Moving to the next one. Thermodynamics done. Moving to equilibrium chapter, discussing the basic of equilibrium. How? By the actual questions. What basic is asked in JEE? Sir, first, Le-Chatelier's principle. So let's say two of the reactions are taking place simultaneously. And how we are disturbing the reaction? We are disturbing that we are subjecting the reaction with more SO2. So let us go to the simultaneous reaction and check what SO2 is. So for the first reaction, SO2 is acting as a reactant. So what is Le-Chatelier's principle? Le-Chatelier principle tells you that whatever change you do to the system oppose the change. So what we are doing to reaction 1, we are increasing the concentration of product. So in order to oppose reaction, equilibrium will try to shift in the direction which will oppose the change. What is the change we are doing? We are adding SO2, which is increasing the concentration of product. So to oppose, reaction will try to decrease the concentration of product, hence reaction will be proceeding in backward direction. I hope we are clear for the first reaction. Now, as soon as the reaction is proceeding to forward direction, SOCl2 will increase and chlorine concentration will decrease. So chlorine concentration not mentioned. SO2 will definitely increase. So SO2 will increase, yes. SO2 will increase, yes. So this and this is correct with respect to SO2, but because it is happening simultaneously, so let us check what is happening with the second reaction. As the reaction is proceeding backward, so it will also force chlorine concentration to decrease because it is proceeding forward, so chlorine will be reacted. In second reaction, chlorine is acting as a reactant and to second reaction it will be it will have a feeling that my reactant is decreasing. So this will also try to oppose. So in order to oppose the decreasing reactant, it will try to increase the reactant. So second reaction will also proceed in backward direction in order to increase the concentration of Cl2. But while increasing the concentration of Cl2, this concentration will also increase, but along with it, concentration of CO will also increase. So concentration of CO will not decrease. Concentration of CO, yes, it will also increase. So actually option 4 is the most appropriate. What about COCl2, sir? It will decrease because second reaction is forced in the backward direction. So because this will decrease, so this is incorrect. Amount of CO, why it will remain unchanged? This is also incorrect. So beautiful example of Lee-Chatelier's principle, and not a general question, a question which will help you to go through Lee-Chatelier's principle very properly. Also the concept of simultaneous equilibrium. Moving to the next one, because most of us have given 4 answer. Good. Moving to the next one. Perfect beta. Black mystery, perfect. Now, one more basic is definitely loved by JEE is, for example, let's say I have PCl5. Now PCl5, we know through chemical bonding also that it is trigonal bipyramidal. So two chlorine have on the axial position are having higher bond length, so they can easily be decomposed. So 2 chlorine moves away and PCl5 therefore decomposes and forms PCl3 and Cl2 gas. So at least I mean in nature this decomposes, 1 mole of this decomposes and forms 1 mole of this and 1 mole of this. What happens is, what is initially present? Sir, initially only PCl5 is present. So sometimes question does not give you the detail via this, question gives you detail via vapor density. Vapor density, we should definitely know that vapor density is equal to molar mass upon 2. Molar mass is actually mass of 1 mole species. So if we talk initially, then initially we have only the reactant. So initially only PCl5 will be present, and 1 mole of PCl5 is molar mass of PCl5. So initial vapor density will be molar mass of PCl5 upon 2. Let us say initial vapor density we are representing as capital D. And at equilibrium, let's say if we are reaching equilibrium, so A minus X, this will be remaining. X and X of these are produced. So 1 mole of mixture will be now termed as molar mass of mixture, and dividing it by 2 will give us vapor density but of the mixture. Let us say that vapor density of mixture is small d. Now capital D upon small d has I'm not deriving that relation because this is not the time to do the derivations, but yes, the most important conclusion is the general basic formula, which is 1 plus n minus 1 times of alpha, where n is the number of fragments this is decomposing into. Because this one guy is decomposing into 2 fragments, so value of n will be 2. So 2 minus 1 is alpha, so this is nothing but 1 plus alpha. Now what is capital D? The vapor density of PCl5. The vapor density of PCl5 is also only given to you, which is this much, as in 104.25 is the value of capital D upon what about small d. When heated, the vapor density is reduced to this much. That means with this will be the vapor density of mixture. So value of small d is nothing but 62. So I hope you can find alpha. Once you find alpha, you will multiply it by 100. You will get percentage alpha. So percentage alpha, you just have to do now into divide. I am helping you with the answer. Answer will be 68%. Do we have some participant who is getting this answer for me? But I want a beta. I want each and every one of you to attempt by yourself. Please do attempt by yourself. Now, moving to the next question. The next question says, again, a very beautiful question. Again, a very beautiful question from equilibrium. From ionic equilibrium actually. The question says, the number of moles of ammonia that must be added to 2 liter this much molar of AgNO3 in order to reduce concentration of silver ions to this much. A very beautiful question. Now what it is asking, what it is giving, that enthalpy of formation of this complex is this much. Sir, value of K is more than 10 to the power 3. That means equilibrium is completely proceeding into forward direction. So what is the reaction? Sir, silver cations interacting with ammonia forming this complex, which is Ag NH3 whole twice plus. What is the value of K for such a reaction? So 10 to the power 8. That means this reaction is tremendously moving forward direction. Okay. At time t equal to 0, what is the concentration of ammonia? Is silver plus? Sir, silver plus is coming from silver nitrate. So concentration is 0.8. So this is 0.8. How much ammonia I'm taking? I do not know. Let's say I have taken C. Concentration. Initially, I have none. Whenever equilibrium is reached, one of this is decomposed, one reacts with 2, so x reacts with 2x, so C minus 2x. How much this will be produced? X. What is the value of K? So 10 is power 8. What is equilibrium constant? So concentration of product upon reactant. Concentration of product is X. Upon concentration of reactant is concentration of silver plus iron at equilibrium upon concentration of ammonia at equilibrium. Now, this ammonia is having stoichiometry 2, so squared. Now, after this, you have to use some theoretical common sense. What is that theoretical common sense? What does this value 10 is power 8 suggest? It suggests that complete reaction is taking place. So once complete reaction is taking place, practically speaking, whatever silver I had, all the silver ions are converted into this complex. Why? Because the value of K is so large. Question is saying silver ion concentration is reduced, sir, from 0.8 as an 8 into 10 raised power minus 1, it is reaching 5 into 10 raised power minus 8 as in 0.000. Arey sir, that means completely silver is gone. Yes. So completely silver is gone as in 1 will give you 1. So 0.8 will give you 0.8. So this X is nothing but approximately the complete silver cations. Although this will help us to predict that this value is nothing but 0.8. But sir, if we take this as 0.8, the concentration of silver ion will be 0. If I put 0 here, everything will be gone. No. Now we'll be doing our mathematical trick. What is that? We know this value is negligible, but that negligible value is given to us. What it is? So this. So now we quickly use our mathematical reasoning and we'll say we know that this is complete formation of the complex has taken place. But complete as in, now we'll deny. No, we didn't say that. At least some much, I mean, very negligible amount will be remaining, and that negligible amount we have to calculate. And it is given us in the question that what is the negligible amount, this much. So rather use the value directly over there. So 10 is power 8 is equal to 0.8 upon 5 into 10 is power minus 8 into. What about ammonia now? Concentration of ammonia we are interested. So what is this? So this is C, which is concentration taken initially, minus. Now value of X we know, 0.8. So 2 minus 0.8 is 1.6. But squared. This will help you to clearly find the value of C. Once you find the value of C, C will be your molarity, which is quite easy also to calculate. Are you asked molarity in the question? No. For ammonia, you are asked moles. So molarity, you know, molarity is equal to moles upon volume. Volume of solution is 2 liters. So whatever molarity or C you will be having, multiplied by 2, you will get your number of moles. I guess your answer will be 4 moles. That means this C will be coming out to be 2. You just have to check with your calculation and you will be getting your answer. Very beautiful question to understand the very important theory of application of equilibrium constant K. So this is using application of equilibrium constant K with the design of mathematical reasoning of a equilibrium problem. I hope everybody is with me on this. बहुत नेगेटिव थॉट आ रहा है अब 7 दिन में कुछ नहीं हो सकता. नहीं बेटा, ऐसा see, everything is a temperament, beta. If you see, I mean, if you see a glass of a bottle of water, although it is a very old saying that it is half filled, some may say half is gone now, I have nothing left. Some may say, "Arey, आधा तो बचा है." So at least with half, I can drink and I can move and live till tomorrow. So this is all temperament, beta. So definitely, as a teacher, I'll definitely advise you to please don't lose that positivity, because hope is the only essence of life. Never lose it. Won't help you actually. Chalo, chalo, chalo. Ravi Kumar, moving to the next question, which says, again, a basic, again, one more questions, but such question of equilibrium also you should leave in the first attempt. This type of question also. Now, tomorrow is something very special, and the special thing is we are coming with the batch announcements at PW JEE English channel, the JEE, the NEET, the foundation. So we are coming up with some good and revealing informations for you. So stay tuned. But yes, those of you who are having that paper, obviously I would be wanting them to spend time in their content. And yes, we are here. We'll be, once you be finishing with your JEE paper, we'll be still be here. So you can all obviously come back later, but this is not the time for you to come to join. You please do not join. You actually invest time in your studies. Moving to the next question. 5 मिनट देख लेना, मतलब 5 ही मिनट. हाँ, moving to the next question. For a reaction at equilibrium as in this, the relation between dissociation constant K, degree of dissociation alpha, and equilibrium pressure. So equilibrium pressure P as in as total pressure. So reaction is A giving B plus half C. So A gas giving B gas plus half of C gas. So let's say I'm starting with initial P naught. So this is 0. So P naught minus X. So this is X and X by 2. And what shall be the total pressure at equilibrium? P. So this is partial pressure of this plus this plus this. X is gone. So this is P naught plus X by 2. Now, we are asked, okay, we have to do with respect to alpha. So because we are supposed to do with respect to alpha, so let me not make X over here. Let me introduce alpha. So this will be P naught 1 minus alpha. So this will be P naught alpha, and this will be P naught alpha by 2. So at total pressure will be this plus this plus this. So minus alpha will be gone. So P naught common 1 plus alpha by 2 will be the total pressure. Now, what are we supposed to do? Sir, we are supposed to calculate equilibrium constant K will be nothing but partial pressure of C. So partial pressure of C is nothing but P naught alpha by 2 raised to the power 1 by 2. What is partial pressure of B? So P naught alpha raised to the power 1. What is partial pressure of A at equilibrium? So P naught into 1 minus alpha. Now, let me take P naught out. So this is P naught raised to the power 1 by 2. So this P naught and this P naught is gone. So P naught raised to the power 1 by 2 into, this is alpha raised to the power 1 by 2, this is alpha raised to the power 1. So alpha raised to the power 3 by 2 upon this 2 is still left. So 2 raised to the power 1 by 2, and this is 1 minus alpha. Now, I do not need P naught. Rather, what do I need? I need P total. So replacing P naught by, so K is replacing P naught by P total, or simply P, because in the question it is given as P. So P upon 1 plus alpha by 2. So 1 plus alpha by 2, and this is 1 minus alpha. Okay. So this 1 plus alpha by 2 into 1 minus alpha into under root of 2, because this 2 is still pending, into, okay, whole raised to the power, because this is P naught raised to the power 1 by 2. So P naught is P upon 1 plus alpha by 2. So P upon 1 plus alpha by 2. Okay. So I should not use this. P upon 1 plus alpha by 2 raised to the power 1 by 2. And rest is not with the power. So alpha raised to power 3 by 2. So this is the problem which you have to attempt yourself, which will give you confidence. Now, so ultimately my overall equation is P having a power of 1 by 2, P having a power of 1 by 2, 3 by 2, no, 1 by 2, yes, 3 by 2, no. So two options are gone. So P raised to the power 1 by 2 and alpha raised to the power 3 by 2. Alpha raised to the power, no. Obviously, I have my answer. Alpha raised to the power 3 by 2. Alpha raised to the power 3 by 2. P, this is 1 minus alpha, 1 plus alpha by 2, 1 minus alpha. Okay, I'll take that as an LCM. So this is, there comes 2 plus alpha and this is 2 under root 2 and this is under root. So they will be getting cancelled. Okay. I mean, not that under root, this 2 and that 2. That 2 is not here. Perfect, perfect. So you obviously have to invest your time for such questions. I mean, the logic is quite simple, but it will be requiring a few mathematical analysis from your side. Once you do it, only then you will be landing up with answer. Now, this is a JEE Mains 2024 question. So such question, I will definitely advise you to leave in the first go. But yes, or to create an edge, after doing the easier questions, you should definitely come back to such questions. Chalo. हाँ बेटा, post mains darshan, we will be definitely coming for advance. For advance, we are most relevant, because obviously mains, yeah, now these days mains has also increased the level, but obviously practically speaking, in a mains level of paper, if you go and search and find easier or moderate questions, even then you do not have to do those difficult questions. But yes, for an advanced level of paper, especially for JEE advanced, that's why we obviously have a big role to play, and definitely we'll be helping you with that. Moving to the next question from Ionic equilibrium, which says the sulfurous acid, which is this, has K1 and K2. This, a very important logic we should know. Once you have an acid which is having K1 and K2 as first and second dissociation constant, it is a common sense which you should know that dissociation constant 1 is not greater, it is much greater. And because it is much greater, that means the second one is much smaller. So if it is an acid and giving H plus ion and it is a weak acid, so the amount of H plus that dibasic acid gives, being a weak acid, the first dissociation constant only decides the concentration of, decides what? The concentration of H plus ion. So rather, although it is decomposing or dissociating in 2 steps, in order to calculate the H plus ion concentration, what dissociation we should only consider? The first one, because second step is negligible. That's why this H3SO3, whatever acid you are, I'm considering it to be a weak acid HX, which is giving me H plus and X minus. The H plus and X minus you are giving me is with an extent of 1.7 into 10 to the power minus 2. So definitely I know you are a weak acid, and for a weak acid, concentration of H plus ion at equilibrium is simply under root of equilibrium constant into concentration of this particular weak acid. So its value of K is, for me it is not, because I'll not say you'll be adding 2 reactions of K1 into K2, no, because this will not contribute anything. So I will only take the value of K1, which is 1.7 into 10 to the power minus 2 into directly its concentration, which is 0.588 molar. Just solve this. I guess this and this will be multiplied and approximating it to be 1. So this is simply 10 to the power minus 2 under root. So 10 to the power minus 1. So H plus ion is 10 to the power minus 1. So pH will be simply 1. So a bingo question, a very logical question. I hope this will, I'm not from general reference. It is again a JEE mains question. So just such basics is asked by JEE. So kindly note them and keep them in your mind. Yeah. Yes, Darshan, don't worry. I'll be definitely coming with more questions once we'll be through with our mains paper for advance. Moving to the next one. The next question says 20 ml of 0.1 molar, 20 ml of 0.1 as in 2 millimoles of this weak base, 40 ml of 0.05, so 4, 5 or 20 as in again 2 millimoles of the strong acid. So sir, strong acid and weak base, 2 and 2. So acid and base will be gone and you will be forming a salt. NH4Cl, which is a salt of strong acid and weak base present in water. So this is just case of salt hydrolysis. How much salt we have formed? 2 millimoles. So what is pH of salt hydrolysis? Sir, because acid is strong, so 7 minus. If base will be strong, then 7 plus. 7 minus what? By a factor of half of, learn this formula, pK of the weaker part, which is base, plus log of C. Now, I feel this much every student does, but where most of the student commit mistake is the putting value part. Let me tell you where. So pH is nothing but 7 minus half of pKb is minus of log of Kb, so minus of log of 10 raised to the power minus 5 plus. Now, most of you will make a error over here. See, what is C beta? 2. Many of the students write 2. It is not 2 beta. It is 2 millimoles, but it is, sir, millimoles. What is volume? 20 plus 40 as in 60 ml. So 2 upon 60, milli will be cancelled. So this is the area where most of the students make mistake and land up with a negative mark. So once you solve it after putting the values of log, now I'm not solving after this because obviously concept is clear. The value of C, sir, C is molarity, which is moles upon volume. Most of the students miss the volume part. They just put the moles. So if you are listening it properly, then please do not do it. Sir, both morning and evening paper discussion will be there. Yes, black mystery, both will be there. Don't worry. As in the January attempt, we have been there with you. We'll still be there with you. Don't worry. Moving to the next one. The next question again from ionic equilibrium, but from the salt, last part of ionic equilibrium, which is salt hydrolysis, which is a solubility of a sparingly soluble salt. Now, a sparingly soluble salt does not completely ionizes in water. Partially, it does ionize. So that partial ionization do what? Will create ions, but it will be creating ions till it is not getting precipitated. At what point it gets precipitated? When its ionic product becomes equal to the solubility product. So for magnesium hydroxide, KSP is given. So magnesium hydroxide will be going as a solid. It will be just giving you Mg plus 2 ions and OH minus ions. To what extent? To the extent it is allowed by the value of its KSP. Its KSP value is given out to be minus 11, which is very small. It will be equal to concentration of ionic product, which is magnesium ion, into OH minus ion squared. Now, because we are given with the concentration of magnesium ion, so we must be putting these magnesium ion from another salt. So what is the concentration of magnesium we have already created in the solution? Sir, we have created 0.1 as in 10 to the power minus 1. So 10 to the power minus 1. This is minus 11. So this becomes minus 10. Becomes OH minus ion concentration squared. So OH minus ion concentration will be 10 to the power minus 5. So POH will be 5. So pH will be 14 minus 5 as in 9. Answer. So this is some basic common sense of solubility which you should know, and once you know it, questions become very easy and attemptable for you. Moving directly to the 12th physical chemistry, which is solution. The first type of question you get in solution is around the colligative properties. So this is a very easy chapter. What are the colligative property? RLVP, relative lowering of vapor pressure, elevation in boiling point, depression in freezing point, and osmotic pressure. After making all those formulas, always include Van 't factor I, which for a dissociation is 1 plus n minus 1 into alpha, and for association it is 1 plus 1 upon n minus 1 into beta, where 1 upon n is, for example, for association you put n as 2, for dimerization, for trimerization you put n equal to 3. Generally you have case of dimerization. So this is complete solution done in this statement. Let us practice some question out of this. Now, PDF of Santosh, this session you will be getting in PW JEE WhatsApp channel, the link to which will be there in the description section. Go to it, join WhatsApp channel. Once we are done with the lives here, the complete notes, all these notes is given to you in the WhatsApp channel free of cost. So please download it from there. If you have not joined the WhatsApp channel, please do it right now. Moving to the next question. Sir, there are two volatile liquid components. Okay, sir, 1 and 2. So Dalton's law and Raoult law tells us that total pressure is equal to P1 naught into X1 or Chi1, which is mole fraction in solvent in the liquid solution, P1 naught into Chi2. Now, we definitely know from Dalton's law that partial pressure of component 1 is equal to P1 naught into X1 as per Raoult's law, but it is also equal to total pressure into mole fraction of component 1 in gaseous form, and gaseous form we write as Y1. Similarly, partial pressure of second component will be equal to partial pressure of second component in pure state into Chi2, which is its mole fraction in liquid solution, is equal to total pressure into its mole fraction in the gaseous state, so Y2. Now, we are supposed to give plot of 1 upon X1 and 1 upon Y1. So how to do that? Just your mathematical reasoning. Sir, how to do this mathematical reasoning? So 1 upon X1 and 1 upon Y1 you have to get in a graph. So let us use the value. Because we know total pressure is equal to this much. Now, as per Raoult's law, total pressure is P1 naught X1 plus P1 naught X2. So X1 I need. What do you not need? Sir, X1 you need. What do you not need? X2. Instead, what you need? Sir, instead I need Y. So replace first X. How to replace X? Total pressure will be equal to P1 naught X1 plus P2 naught. I'm sorry, this is P2 naught. This is P2 naught of that 2 into 1 minus X1. Ultimately, I have removed what? Sir, I have removed the X2 part, but I need Y1 also because I have P total. So let us, instead of this P total, what I can write? P1 naught X1 upon Y1. So this P total is replaced by something which is having Y1, and over there it is quite evident now. Taking this is P1 naught X1, this is minus P1 naught X1, so taking X1 common, so this is P1 naught minus P2 naught plus P2 naught. I hope everybody is clear with this. Now I need 1 upon X1. So let me bring 1 upon X1. Let me bring X1 on that side. So I'm having 1 upon Y1 over here into P1 naught will be equal to X1 going there. So this is P1 naught minus P2 naught plus P2 naught into 1 upon X1. Now, this is my Y. This is my X. So this is my Y and this is my X. So let me just rewrite this equation as Y is equal to, because I can clearly see it's a straight line. So 1 upon X1 is equal to, this was Y is equal to mx. So I need this. So 1 upon Y1 into P1 naught upon, that will come to the denominator, P2 naught. That will come this side. So if coming to this side, this will become P2 minus V1. So plus P2 naught minus P1 naught upon P2 naught. So this is my constant C. So we are asked the slope. So slope is P1 naught upon P2 naught. P1 naught upon P2 naught, as in this or this. And what about intercept? P2 minus P1. P2 minus V1 upon 2. Option 1 is your answer. Let me check. Yeah, perfect. So it's just mathematical deduction you have to do, which will require time. But this is what the basic colligative properties will be asked to you with some mathematical reasoning behind it. So for this reasoning, you have to put in some efforts, and that efforts can only be fruitful once you practice yourself. So after this session, please revise properly, my friends. Perfect black mystery. Moving to the next question, which says again, once you add two volatile component, they form an ideal solution, but they can form non-ideal solution also. Non-ideal solution are of two types: positive deviation and negative deviation. What are the famous example of negative deviation? Whenever you have some special attraction force between them, though they are the examples of non-ideal solution showing negative deviation from Raoult's law. Learn these examples because most of the students miss these examples. So I have almost in all the paper which you have for a mains level of question, although for an advanced level of question, these are the examples I want you to learn. They are famous examples of solutions showing negative deviation from Raoult's law. Now, coming to the question here, it is also asking about the azeotropes. Now, azeotropes are mixture who have same x1 and y1, same x2 and y2, as in their mole fraction in liquid phase and in vapor phase are equal. The basic definition of azeotropes. Again, there are how many type of azeotropes? Minimum boiling azeotropes and maximum boiling azeotropes. How to remember them? Minimum boiling azeotropes have minimum boiling point from their components. So in order to have minimum boiling point, what type of deviation you should show from Raoult's law? You should definitely show positive deviation from Raoult's law. So among the given options, now let us read the question. Which of the following binary mixture does not show? So who does not show positive deviation from Raoult's law? As in, it is asking us about the negative deviation. So out of them, alcohol and amine are attracted to each other by intermolecular hydrogen bonding, and hence it will show negative deviation from Raoult's law, and hence not positive deviation. So it can't show minimum boiling azeotropic mixture. I hope everybody is clear with this. Good question. Perfect, Reddy. Learn these examples, beta. Moving to the next one now. Again, a beautiful question. The question says, this is solution on the slide X. This is solution on the slide Y. Now, concentration of copper sulfate is 0.05 and concentration of potassium dichromate is 0.01. This is number of moles of solute upon volume of solution. Now, we definitely know here number of moles of solute is more. So because solute is more, so solvent is less. So that means here solvent is more. And because solvent is more on X side, so solvent will move from X to Y. Who will move? Solvent. Why? Because through a semi-permeable membrane, only solvent can move, not solute. Now the question is tricking you. It is telling you that this and this gives green color solution because of formation of some compound. Sir, color will be shown when solute will be interacting. We know through a semi-permeable membrane, solute can't move. Who can move? Only solvent. So, do you find any color? No, sir, because solute is not at all moving. So, do you see green color? Go to hell. No, I'll not. Yes, concentration will change because ultimately solvent is going. So because solvent is moving away, solute is same. So here concentration will increase. But because this is getting diluted, so here concentration will fall. So concentration will fall for copper sulfate. Yes. Concentration as in molarity, no, it will be increased. So this is wrong, and definitely option 4 is the right answer. Beautiful question. I hope everybody got this. Moving to the last and painful part of solution chapter, the Henry's law. We should all definitely know that partial pressure of gas over solution is equal to Henry's law for that gas at that particular temperature in that particular solvent into mole fraction of that gas in the solution. So if you have to compare the solubility of two gas, then we take the partial pressure as constant for two gases. So for a gas who is more soluble will have lesser value of KH. Similarly, if a gas is having higher value of Henry's law constant, then its solubility in particular solvent will be less. I hope everybody is clear with this. Now, in this question, we are given Henry law constant for 4 gases. Alpha has highest solubility in water. Now, we have definitely implied this. It is saying because for alpha, K is highest. Now, because K is highest, that means its solubility will be least, not highest. So, because it is saying highest, so it is wrong. I hope we are directly coming to the conclusion. Option 2 is saying solubility of gamma. This at this temperature is lower than yes. If you increase the temperature, solubility will get decreased. But are you implying this from this data? No, sir. This we know because we know through common sense that as you increase temperature, solubility of gas will decrease. But this we are not implying by the value of K. So option 2 is correct, but this is not an implication from the given data, and the question is asking us, what do you imply from this? A very beautiful question. Although this is correct, but not implied from the given data, hence I am not considering this as an answer. The third says the pressure of, now here we have to do into divide. This is molality, and this for delta we have to do. So for delta as in this, so value of KH is 0.5. Let us find value of pressure. So partial pressure, let's say I do not know how much pressure it is. So partial pressure of delta will be KH, which is 0.5 into its mole fraction. Now mole fraction is number of moles of solute. So 55.55 molar means I have this much moles of solute. Number of moles of solute, let's say, is N2 in 1 kg of water. So 1 kg of water as a number of moles of solvent will be 1 kg is in 1000 gram upon 18, which is also, I hope everybody remember, 1000 by 18 is also 55.55. So what is mole fraction of gas? Sir, N2 upon N1 plus N2. So this will definitely be 55.55 upon 55.55 plus 55.55 taking common. So this is 1 by 2. So this is how much? Okay, the value of KH is given out to be in kilobar. So into 10 raised to the power 3 bar. So 1000 divided by 4 bar, as in 250. Yeah. So this is correct. This is incorrect. A beautiful question. A beautiful question. Beta, this is not enough, beta. Beta, this is not enough. This is more than enough. Moksh, more than enough. Why I'm saying? Because if all those students who are missing chemistry, then with these questions you can at least revise most of the chemistry. Most of the chemistry with most of the logics, which is definitely most probable for your JEE paper. Moving to the next one. Now, directly moving to electrochemistry, and with electrochemistry, I am starting with the basic, extensive and intensive function now, which is additive. Sir, Gibbs free energy. Gibbs free energy has an additive nature. So if you add two reactions, Gibbs free energy change can be added, but what is not dependent on amount, sir, potential. Therefore, if we are required to calculate potential, what you have to first do, convert that potential into Gibbs free energy. How to do that? Everybody should remember this formula, that delta G naught is equal to minus NF E naught of that particular change. So because we are asked the reduction potential of FeO42 minus 2 Fe plus 2, but we are given FeO42 minus 2 Fe plus 2 in 2 sequence. So let me first make FeO42 minus going to Fe plus 3. Let us find oxidation state. Sir, this is 2 minus, na? So this is plus 6 and this is plus 3. So how many electrons are getting transacted? So 3 electrons. What about plus 3 to plus 2? It is quite easy. Fe plus 3 getting to Fe plus 2, how many electrons are getting transacted? Quite easy. This is 1 electron. So if we add these two reactions, plus 3 will be getting cancelled. FeO42 minus transforming to ferrous ion. Because I'm adding, so 3 plus 1 becomes 4 electron. Let's say delta G for this reaction is delta G1. For this, it is delta G2. For this, it is delta G3. Now we can clearly see that delta G3 is nothing but delta G1 plus delta G2, because Gibbs free energy is additive but potential is not. So in order to estimate potential, first do quantification on Gibbs free energy, then use the formula of Gibbs free energy in terms of potential, which is minus NFE. So here minus, what is the electron transferred? 4F, this E naught I have to determine, equals for the first reaction minus 3F, what is E naught for this half? 2 volt, plus minus 1F, what is E naught for this half? 0.8. Now the calculation is your job, guys. Obviously everybody is seeing F can be clearly cancelled, negative sign can be clearly removed. Once you solve, let me help you with the answer. You will be getting E naught as 1.7. Do I have a participant? Yeah, black mystery, perfect. Moksh beta, the reason I'm discussing the questions to great extent, I would have done, acha ye raha question, made the answer in the next slide, this is how you solve it, and iterate that. My energy will be halved. I can easily do this. I can ask my DTP to write these solution. I stand over here and do laser. Beta, this. The reason I'm solving with you is I want you to go through all the basics with me. I want you to go through all the basics with me. I want to get stuck where you will get stuck. And that's why we can be in sync. And this is how every lecture should be delivered. I have seen most of the teachers doing this, that they bring question on one slide and solution on the other side and do laser marking. 50% of the job is not done. Why? Because teacher will not feel the pain, because doing into divide is not easy actually. So even I am skipping that into divide, but I am skipping just the last part. And why leaving that last part? Not because I can't do that into divide, because I want you to go back to this question. You will go back to validate whether answer is coming. While going back, you will again see the question. This is how you read and remember the question. So in order to remember the concept, this is the only way we practice. Once we used to teach in our 2012, once we have started our coaching back 2012, 2012, yes, first year. We used to sit with 6-7 students, complete day, साथ में करो, सामने करो. And once you start doing those questions in front of the teacher also grows with you, because we don't practice question, you practice question. So never mind. Hey, we have less time, beta. Let us. Okay. Vishwajit. Sir, I'm afraid. Don't be afraid, beta. Work. There will be no scope of having a feeling of excitement, happiness, or sorrow, or afraid. You can only have those feelings when you have a side of your brain which is not working. If you invest yourself to a job, you will do job. Why you will be feeling depression or happiness or anything? Once you give buffer to your brain, then you start, अरे अच्छा नहीं लग रहा है, काम ही इतना है, तो ये सोचने का वक्त ही नहीं मिलेगा कि अच्छा लग रहा है कि खराब. So start working, beta. Every feeling will be gone. Don't worry. Moving to the next question. The next question says, assuming that hydrogen behaves as ideal gas, what is EMF of the cell at 25 degrees Celsius? Very good question, very probable question for your JEE paper also. If you see the cell reaction, you just check. Hydrogen is getting oxidized and hydrogen is getting reduced. That means, which is getting oxidized? Hydrogen. From 0 to +1. So hydrogen gas from 0 to +1 is getting oxidized, 2 electrons. But this hydrogen gas has a pressure of P1 bar. The same hydrogen gas, yes, same as in with different pressure. So hydrogen gas is doing reduction also, but in the cathode half, what is the pressure with this hydrogen is used? P2. Because ions concentration is not given, that means it is taken as standard concentration. So let's say it is 1 molar or whatever molar concentration will be getting cancelled. So why bother? Ultimately, we are having this as H2 gas at pressure P1, giving us H2 gas at pressure P2. So writing Nernst equation for this, electrode potential is equal to standard electrode potential, which is 0 because hydrogen, cathode hydrogen. So this is a concentration cell. So electrode cell potential is equal to standard cell potential minus 0.059 as in 0.06 upon number of electron transferred as 2 into log of, instead of constant for a gas, pressure of product upon, instead of K I'm writing Kp or QP. So P2 upon P1 raised to the power 1 because stoichiometry is 1. Now, what are we asked in the question? Okay, P1, P2 value is given. So P2 by P1 is 420 upon 600. So this is 42 upon 60 as in 2 ja or 6. Acha, 6 7 ja 42 na? Upon this is 7 by 10. So put this as 7 by 10. So log 7 minus log 10, log 7 is 0.85, log 10 is 1. So do your maths. This is 0.03 and you will get your value of E cell. I'll help you now. This is just into divide. Come back to this into divide. Your answer will be this. Obviously, it will coming out to be positive. Why? Because 7 by 10. So log 7 minus log 10. So log value will be negative. The negative will become positive. I hope everybody, do we have somebody getting the answer? Believe in process. I'm afraid perfect. Black Mystery is advising Vishwajit, beta, please do that. Please believe in yourself. Salt analysis, Sagar, today I have not taken that cationic list. You can find that cationic list in rank booster test series or in the inorganic live discussion which I have done, because in the last 5 hours, 5 days I mean, some students don't feel comfortable in reading new stuff even I don't advise them. But yes, those who have done that cationic list is just to do the cation segregation in salt analysis, and it is more than sufficient for salt analysis. So this finishes this question. Moving to the next one, which says at 298 Kelvin the standard reduction potential of this copper electrode is this much. Okay, KSP is given. So this is a metal insoluble salt electrode. Because we are having electrode potential of copper forming copper solid. Now the copper ion are given by what? By this insoluble salt. So if I need to calculate the electrode potential of this, okay, the electrode potential is given. It is 0.34. Okay, the standard value is given. So as per Nernst equation, electrode potential of copper plus 2 to copper will be standard electrode potential, which is 0.34 minus 0.059, or maybe, okay, it is taken, okay, I'll take 0.06 upon 2 into log of, this is product, so 1 because pure solid upon copper plus 2. So my only job is to calculate this copper plus 2 aqueous concentration. But this copper plus 2 ion is given by whom? Is given by this sparingly soluble salt. So this copper hydroxide forming copper plus 2 and OH minus ion will be very less because its KSP is very less. So KSP is this much into copper plus 2, how much concentration it is creating, that I have to calculate, and I'll put that value over here. But in order to find this, I need OH minus ion concentration. Now the in data is telling me the reduction potential. Okay, it is giving me the pH. So this sparingly soluble salt is kept at a pH of 14. So because pH is 14, so POH will be 0. So OH minus ion concentration will be 10 raised to the power 0. Okay, 10 is minus of log of, okay. So minus of log of OH minus ion concentration is 0. Okay. है ना? So 10 raised to the power, what is 0? So minus of log of OH minus ion is 0. So this is base 10. Okay, so OH minus ion concentration is 10 raised to the power minus 0. Acha, anything else is 1. The basic maths. So this is what I need a break. So 10 is power 0 is 1. So that means OH minus ion concentration is given out to be 1 squared. So this clearly gives you concentration of copper plus 2. So concentration of copper plus 2 is how much? 10 is power minus 20. So this is 10 is power minus 20. You put this 10 is power minus 20 over here and definitely you can find your answer. Into divide I'm helping you with. Once you solve, you will get 25 as your answer. Okay, you must be getting this value as 0.25 because you are asked answer in the form of, okay, minus 0.25 you'll be getting. So just check, you will be getting minus 0.25 and answer would be minus of 25 into 10 is power minus 2. So your answer value of x will be 25. I hope everybody is clear with this. Black mystery is saying 26. Beta, just check. Acha, pata hai black mystery why 26? Because it is telling us to take 0.059 and we have taken 0.6. Actually, we should not approximate this also because it is considering our calculation till 2 place of decimal. That's why 10 is power minus 2, no? So don't make that error. Take this as 0.59 because value is very small. See, the question is tricking us with mathematical justification also. So leaving such question without discussing the calculation part will be a crime for if you talk as a teacher. So I hope we are making sense with this. Moving to the next one. Now, titration, conductometric titration questions, students fear a lot. Let me help you with one question which will be helping you to remember the concept also, and a good question I'm having now. Choose the correct representation of conductometric titration of benzoic acid. Now, benzoic acid is a weak acid. So let's say I have a weak acid in my solution. Solve more question in chemical kinetics. Haan beta, chemical kinetics also I'm having few questions. Don't worry. I will be doing my job to the best of its efficiency. Don't worry. Now, benzoic acid is a weak acid, so it will be giving us very small amount of. Now that I am 35 from now, when you have questions, I paused and did myself, then watched the approach and now saw that I am in a delay. Sir, I observed now that I am in a delay of 55 minutes from now. When you have a question, I paused and did myself, then watched your approach and now saw that I am in a delay. Okay. So beta, I mean, yes, you have to find an approach of working with a teacher because we are obviously coming in a YouTube live. So obviously, the method with you can utilize our working will be subjected to students. So yes, if at all you feel you got a delay, then change the approach. Maybe start attempting with me or pause the video and then attempt. So I mean, you have to find out a way which is best and more efficient for you. Beta, it will be looked. It will not be good beta, it will be great, but yes, after attempting you should definitely make a point of revising the content, because once you attempt the first time, everything is not coming in sync over here. It comes in sync once after the attempt you revise also. And I'm not saying revising by, if I'm attempting today, I'll revise tonight. No, take a pause of a day because we are not having any time more, but take at least one 12-hour break, do something else and then come back to these questions. Then only it will be termed as a revision. Now, so ultimately I'm having a weak acid. A weak acid like benzoic acid will be breaking and giving very small amount of C6H5 COO minus and H plus. Now, because it will, let's say it is a weak acid, so out of the 100 molecules, 95 will not be associated and 5 and 5 is the number of ions that it will be producing. Now, as I bring strong base, which is NaOH from outside, Na plus, the first drop, the first molecule of NaOH will do what? Sir, it will neutralize H plus and form OH minus ion, and instead of H plus, it will plant Na plus. So we definitely know H plus has the largest conduction tendency. So the first 5 H plus will be gone and be replaced by first 5 Na plus. So therefore initially you find a dip. Why? Because initially, although the amount was less, let's say 5 H plus were there, but now though initially when 5 drops of NaOH is coming, 5 molecules of NaOH is coming, 5 H plus are replaced by 5 Na plus. Hence initially you will find a dip because H plus has larger conductivity than any of the cation. Now once the 5 molecules of NaOH have neutralized H plus, after the 6th molecule of NaOH which is coming, because it is a strong base, so it will be dissociating, and now it will be forcing the 95 benzoic acid molecules to further dissociate, and therefore this strong base will force the weak acid to dissociate, and because of the dissociation, conductivity will still increase. And after the complete neutralization has taken place, as in 100 molecules of base of the acid is neutralized by 100 molecules of base, after the introduction of 101st molecule of strong base, this will give me extra Na plus, extra OH minus, and now OH minus, and again like H plus has a huge conduction tendency, and hence after neutralization the conductance will increase more rapidly. So option 2 is your beautiful Kavya. Perfect black mystery. Okay, thank you sir for OC. हाँ बेटा, for organic chemistry I have done a live session for organic also beta, but yes, if you are wanting to for luked, you want to practice yourself, so definitely PYQs are the best possible area you can practice your standing, your current standing in your preparation level. If you want to check, then obviously you should attempt those PYQs by yourself. If you find any problem, you can always come to the live discussion and ask the questions. Moving to the next one. The basic Kohlraasch law, for a weak electrolyte, so this is a rectangular hyperbola. For a strong electrolyte, it is a straight line, a very famous Kohlraasch law application. Now, we have to identify the number of incorrect statement. So lambda m as in limiting molar conductivity for electrolyte A. A is a weak electrolyte. Can be obtained by extrapolation? No, because it can be obtained by extrapolation for B, which is a strong electrolyte. For electrolyte B, this is a straight line. Yes, this is definitely correct. At infinite dilution as in at concentration to be 0, the value of degree of dissociation approaches it approaches unity, because at infinite dilution every electrolyte, even strong or weak, behaves as a strong electrolyte, and for a strong electrolyte degree of dissociation is 100%. So alpha is approximately 1, not 0. So this is also incorrect. A is also incorrect. B is correct. Lambda m for any electrolyte A and B can be calculated using this is actually Kohlraasch law, that you can add limiting molar conductivity of the constituent ions, that will give you the limiting molar conductivity of the electrolyte, whatever it is, strong or weak. So this is also correct. So how many correct statements you have? 2. So your integer type answer will be 2. Moving to the next question. Now, black mystery tomorrow, I don't have class. The same 50 questions you will be getting for physics, and after at around 7 p.m. Dipen sir will be taking this class, having important questions. So because Dipen sir is going to come at 7, so let me finish and wrap up before 7. Moving to the next one. Now the next question says from chemical kinetics, we have directly came to chemical kinetics. Now from chemical kinetics, this is also a JEE 2019 question. It says 2A gives product is the reaction. Now concentration of A, B and reaction rate is given. Now if you see, if I have kept concentration of A constant and increased concentration of B, sir, nothing is happening to rate. What does this tell you? That if you change concentration of B, nothing is happening. That means rate is directly proportional to concentration of A raised to the power, I don't know, but with respect to B, order is definitely 0. Now after analyzing this, let us do it for A. For B, we obviously know, and after knowing this, if we quantify it for A, so here I am doubling the concentration of A. Let us analyze what is happening to rate. So this is becoming 6.93. So this is becoming 13.86 because power is 10 to the power minus 3. So minus 2 becomes minus 3. So this is also doubled. We can clearly observe. So that means 2 raised to the power, what is 2? 1. So that means order with respect to A is 1, with respect to B is 0 now. That means this is clearly a first order reaction. Now time in minute required to consume T half. So we have to identify T half of a first order reaction. So for a first order reaction, T half is nothing but 0.693, which is ln2 upon K. So how to calculate K? Definitely I can calculate it, use any of the given data because I know the rate expression. So rate, which is 6.93 into 10 to the power minus 3 is equal to rate constant K, that I have to calculate, into concentration of reactant A raised to the power 1, concentration of B I'm not putting because its power is 0. Done. So you can find value of K from there. Put over here, you'll definitely find T half. Let me help you with the answer. It will be very easy for you to calculate, but please practice it. Your answer will be coming as 10. That will help you to practice also, revise also, and maintain your proficiency also in the subject. So come back to these questions for validating and practicing the answers. Moving to the next one. The reaction is following first order kinetics. So A forming B and C is following a first order kinetics, and we have to, the reaction was started with reactant A, which of the following. So we have to find the integral rate law in form of P infinity, which is total pressure at infinite time, and PT as in total pressure at time t. Now let us do the basic. Again, a very beautiful question. A giving us B and C gas. So let's say initial I'm starting with P naught. So initially I'm having nothing. At time t it is P naught minus X. So here X and X, and at infinite time this is 0. This is infinite time. So everything of A will be gone. So P naught and P naught will be produced because 1 forms 1 and 1. What is given? P at infinite time. So P infinity as in total pressure at infinite time is this plus this plus this. This is gone. So this is twice of P naught. Total pressure at time t is equal to PT. So this plus this plus this. So PT is equal to P naught plus X. For the first law, for the rate expression, what I require, so everybody knows the formula. KT is equal to ln of initial concentration or initial pressure of A upon concentration of A that is remaining at time t. So actually I need initial pressure upon P naught minus X. So this I need in form of P infinity and PT. So I guess P naught I clearly have in form of P infinity, but P naught minus X I need. So let us find value of X from here. So P naught minus X. P naught I know it is P infinity by 2 minus X. So X is PT minus P naught, and P naught I definitely know is P infinity by 2. So plus 1 by 2 minus 1 by, I'm doing something wrong or what? Okay, let us find, ultimately we know this. So let us find X from here. X will be PT minus P naught. So P naught minus X will be P naught minus PT plus P naught. I need to find P naught minus X. Okay, total pressure is this plus this plus this. So P naught minus X plus X is P naught plus X. So PT is P naught plus X. So X is PT minus P naught, and P naught minus X is, okay, P naught minus PT, and minus minus will become plus P naught. Okay, so this is fine now. P naught minus PT. I ultimately do not require this. So instead of 2 P naught, I'll be writing P infinity. So P infinity minus PT, yes. This will consume your time, yes. If you are practicing it beforehand, so it will be saving your time. So KT is equal to ln of P naught is how much? P infinity by 2. And P naught minus X is how much? P infinity by 2. P infinity minus PT. So let me check P infinity by 2. The 2 infinity, no, P infinity by 2 and P infinity minus PT. Yeah. So option 3, I guess. Let me check. हाँ beta, perfect. So beta, लेकिन हाँ, for such questions beta, you have to be vigilant with the calculations, and if you are vigilant with the calculations, then obviously you will require less time as as compared to other students. So you have to be time effective. So 3 and 4 are same options. Okay. 3 and 4 are same options. हाँ beta. So there must be some printing error. Obviously we have calculated our answer. So we know where we are standing. Moving to the next one. The next one says a very rather conceptually sound question which is telling us that for a complete reaction A to B is the slowest step. Now this is a JEE Mains question. A to B is the slowest step. That means what? Activation energy will be highest. So activation energy will be highest for forming A to B. Yes, this is showing highest. It is not, because here C to D is showing highest peak, so this is wrong. Here also C to D is showing highest peak, so this is also wrong. Here also A to B is having highest peak, so this will be the slowest step. So this we have validated in 1 and 2, 1 and 4. Now B to C, which is second step, is exothermic. C to D, which is fast and exothermic steps. That means B to C, C should have lesser energy. Yes, this is quite evident. I mean, very small difference, but yes, ultimately the C is less. But if you see here, this is quite clear that C is having more energy. So here delta H will be positive, which is not in accordance with the data given. Hence 4 is wrong. So only option 1 will be correct. Perfect black mystery. Moving to the next one. Now, for such, because we definitely know that rate constant K is equal to Arrhenius constant A into exponential of minus EA upon RT. Because I know I have a power of exponential of minus E upon RT. So if you multiply two reactions, as in if you multiply rate constant of two reactions, this will be getting added. And if you are dividing any rate constant, it will be getting subtracted, and whatever is there in the power will be multiplied. So here power is 1 by 2. So ultimately for rate, what I'm saying, for first and second, for first and third, activation energy will be added, because I'm dividing by second. So for second it will be getting subtracted, and whatever power which is 1 by 2 I'm having will be multiplied. So power is 1 by 2. So this multiplied by 1 by 2 will be this. The activation energy for first is 60, for second is 10. So 60 plus 10 is 70. Minus for second it is 30 upon 2. So this is clear, it is 20. I mean, you can definitely use this formula, and you can also explain this, you can also prove this. But why proving? Because after doing chemical equilibrium, this becomes very easy for us, very predictable for us. So moving to the next one. Now we have completed the complete physical. Now rushing directly to organic without a break, because you will be having your mathematics paper after this. So I have to let you go by before 7 actually. So let us not take break and just sip water for 2 minutes and we'll be proceeding. So actually let me answer this question for me, guys, by the time I sip some water. Because we can't take break, because you have less time. That's why we are coming up with for you in multiple sessions. Chalo. Chalo beta, let's start. Now, although discussing physical was difficult, because there we have explanations also. Organic and inorganic are the easier side of chemistry. What you have to stick with is the logics, all the NCERT reactions, and whatever logic you require, I'll be using those logics with NCERT facts. Physical and inorganic and organic are the actual area where you should invest more amount of time back at home, because once you are familiar with NCERT, things are quite easy in a paper also to attempt, like these questions. So the first question is, what is the sum of position number assigned to bromine atom? So this is discussing the question. So Dhaja beta, don't worry, even if you are weak, whatever questions I'm discussing right now, na, at least study these questions, not learn their answer, but learn the logic. So this is the question I'm using to help you with IUPAC nomenclature. Like, let us do the numbering. So minimum number is given to functional group, then multiple bond. So multiple bond here will be getting minimum number. But here, if I give 1 to this, it will also be giving minimum number to the branch, which is this methyl. And because I'm giving 1 over here, so I have to do 2, 3, 4, 5. So bromine this way will be getting what position? 6. Similarly here, minimum number will be multiple bond, but multiple bond is having 1, 2, 1, 2. So either side it is tied. Branches also at 1, 2. But if I number from here, the bromine, which is the next branch, will be getting third number. So this proves the lowest location rule. So that's why here bromine is getting third number. Over here, because I have to give minimum number to multiple bond also and with to branch also, so rather taking 1, 2, 3. So here bromine is getting 1 number in the numbering. Similarly over here, 1, 2, 3, 4, 5. So this is how we have revised the IUPAC numbering with a good question. And in the question you are asked to that whatever number bromine is having, you give us the addition of the position. So here it is 6, here it is 3, here it is 1, here it is 5. So answer is 15. I hope we can crack question also. Sunita, I hope 12 is not the answer, 15 is the answer. You are clear with this now? Now, moving to the next one, a very famous reagent table. So practicing question also, trying to learn the logic also. Nitro compounds on reduction with metal in acid gives corresponding amines. So nitrobenzene forms aniline by reducing with metal in acid. So one is clearly Q. Nitrile forming corresponding 1 degree amine by strong reducing agent like lithium aluminium hydride. NCERT facts. Diazonium chloride can undergo bromination by Sandmeyer's reagent or Getterman reagent, which uses copper halide in HX. So copper halide in HX. Aniline, being a strong electron donating group, is a powerful activating group. So if we have bromination, even if there is no Lewis acid, because it is so activating, it will activate the benzene ring at ortho and para position. So heavy activation will allow Br plus to be formed in as much number as it can. It just require a polar solvent. So polar Br2 in polar solvent will create so many Br plus that it will be excessively substituted in ortho and para position. So definitely 4 is R. So 1. So obviously, answer I am giving. Okay, where is the options? Okay, here is the option. Obviously, if you have seen that, clearly it is your answer. Yes, Karthik. Yes, Kumar. Perfect. Perfect. Moving to the next one. The best sequence for synthesis of from carbonyl compounds, mixture of carbonyl compound, aldehyde, ketone, alkanes is done by NTA. That is also I am doing for you. So best sequence for synthesis of pentane 2-on. So pent as in 5 carbon, 2-on as in this. So for its preparation, which is the best method with Grignard reagent, this is R minus getting to carbonyl carbon, but it will form an alcohol. So because this forms an alcohol, so not an answer. Yes, nitrile will receive Grignard reagent and post hydrolysis, yes, it can form. So this is a 4 carbon chain, 1, 2, 3, 4. So 1, 2, 3, 4. The fourth carbon is attacked by CH3. The methyl is coming from Grignard reagent, double bonded N. And after hydrolysis, yes, after hydrolysis, this will get OH. 2 OH on one carbon is not possible, so it will become a ketone. That nitrogen will be released in form of ammonia, and yes, it will give you acetone because this will be the second carbon. So obviously 2 will be our answer. Let me check the other options for you. 1, 2, 3, 4. So first Grignard reagent will come and attack this carbonyl group where chlorine will be removed, but after chlorine removal this will again have a carbonyl group, so one more alkyl group will be coming and it will again form an alcohol, so an alcohol, not a ketone. Similarly, this once any Grignard reagent is furnished with whatever possible solvent, even water can give H plus, so water giving H plus to this R will give you in fact propane, not acetone. So obviously option 2 is our answer, but I'm explaining other options also to help you learn the famous reactions of NCERT. Beta, for bridge course for class 11 to 12 for chemistry, it will be happening on 30th. For physics it is happening today, but at PW English medium channel, not here, not at JEE channel, PW English medium channel. Now again, a very beautiful question from the chapter of ether. We definitely know ether is a polar molecule, so once heated it will form carbocation, but which carbocation will be formed stable? So this carbon is electronegative because it is sp2 hybridized. This carbon is sp3 hybridized, and it will be easy to form carbocation over here. So this fragment will be broken like this. So C double bond C, single bond O minus. This is the first fragment, plus this carbon, which is CH2, will be getting a positive charge. Why? Because this is resonance stabilized carbocation. So I hope these two fragments is very clear to everybody. But this plus and minus can attract, but actually you definitely see this is also a resonating structure. So here, which is a better donor, oxygen as minus or carbon as minus? Obviously its resonating structure will give you a better donor, where this CH2 getting CH2 minus will be a better donor, and this oxygen will become a will have a carbonyl bonding with this carbon. So this minus now will be falling in love with this plus, and therefore what membered ring? 1, 2, 3, 4, 5. Okay, not a ring, but a 5-membered carbon chain will be formed. So let's say this is CH double bonded O. This CH is connected with a CH2. This CH2 has attached with another CH2, which is connected with C double bonded C. Yes, this is also H, this is also H2. Now, this is the product which will be after heating. So this will be, okay, so, okay, this will not be A. This is what happens once we have heated, this reactant. So this is my product after heating. After heating, we are treating it with hydrazine in basic medium. So everybody knows that hydrazine in basic medium is a reduction, is a Wolff-Kishner reduction. So on Wolff-Kishner reduction, 1, 2, 3, 4, 5-membered alkane, because this carbon will be converting into alkane. So 1 double bonded 2, 3, 4 and 5. I'm just writing this CH as CH3 because we definitely know Wolff-Kishner reduction turns carbonyl group into corresponding alkane. Moving to the next one, this is what happens when second step has taken place. Third step is simply reductive ozonolysis. Reductive ozonolysis does not leave the carbon double bonded carbon. It breaks double bonded carbon and introduces double bond O, double bond O. So this double bonded O means CH2OH. So this is nothing but formaldehyde. And this is a 4-carbon chain. So 1, 2, 3, 4 carbon chain getting double bonded O by reductive ozonolysis. So this is nothing but butane 1-ul. So this is not butanol, this is not butanol, this is not butanol. So obviously none of these is my answer because answer is butanol. A very important and a good question. Again, in organic, I'm not taking number of questions. I'm taking limited questions, but in those limited questions, I'm giving you all the possible logics, which will be actually one question for you in your JEE paper. So I hope you are comfortable with what I'm trying to do with organic and inorganic over here. So black mystery beta for search. See, for cis and trans, I'm telling you. See, you must be asking about the Lindlas catalyst and Birch reduction. See, once you have an alkyne, alkyne can be reduced, but after complete reduction, it forms alkane. If you want to restrict the reaction to an alkene, then what can you do? What are your options are? If you use palladium, but poison the palladium with barium sulfate, sulfur, quinoline in boiling solvent of xylene. This is known as Lindlas catalyst. So you stop the reaction at alkene stage, but what form of alkene? Cis form of alkene. Rather, if you use reduction in presence of metal like sodium and in liquid ammonia, then in such cases, partial reduction is done. Alkyne forms alkene, but what form of alkene? Not cis form, trans form of alkene, because that regio-specific nature is such a way you do not have to know the reason for a mains level of question. So just know and learn this for a mains level of question, that Lindlas catalyst produces cis alkene and Birch reduction produces trans alkene. That's it. That's it. I hope black mystery it's clear. Moving to the next one. Now, select the major product. Now, a very important question, dehydration of alcohol forming alkenes. So let's say this is an alcohol. So whenever we approach this alcohol with some acid, so the alcohol gets protonated and forms a carbocation. So what carbocation I'm forming? 4-membered ring. 1, 2, 3, and this is a carbocation. Obviously, we know first ring expansion takes place because 4-member ring is having a ring Beer strain, and because of that Beer strain, ring tries to open up till 6-membered ring is formed. But yes, 4 will form a 5, but yes, 5 will try to form a 6-membered ring. So 4 will try to form a 5-membered ring. Obviously, positivity will be coming over here. So this 4-membered ring will turn into a 5-membered ring. This carbon, let's say, is having 2 carbon group. The next carbon will be attaining a positive charge. Now, because this is a 2-degree carbocation, so after ring expansion, rearrangement will also be happening, where hydrogen will be moving as hydride and positivity will be coming over here. So again, I'm having a 5-membered ring with this ethyl group and a positivity over here. Now, obviously, I can have now beta elimination. So the deprotonation of either this carbon or this carbon will form this alkene. Deprotonation of this carbon can form this alkene. But obviously, once this alkene is formed, this is still a 5-membered ring. 5-membered ring having that Beer strain. This is having a 5-membered ring, although although this is also having same inductive effect, this is also having same inductive effect, but I'm saying this is a better answer. Why? Because of the formation of alkene, Beer strain is removed. Why? Because now this carbon is not tetrahedral, this carbon is trigonal planar, and it will be try to be at an angle of 109 degree 20 minutes. So because this is still a 5-membered ring, but because strain has been reduced, therefore that should be a more stable product instead of this. I hope everybody is clear with this. A very good explanation of more logics combined in one question. Moving to the next one. Amines, sir, Gabriel theramide synthesis produces 1-degree amine. So the question is asking us, what are the isomeric aromatic amines with molecular formula this? Ultimately, because it is having 8 carbon and 11 hydrogen, that means I definitely have to use a benzene. So if I use a benzene ring, what are the possible of using this many carbons to form a 1-degree amine? Sir, ultimately, if you require a 1-degree amine, then this is aromatic amine is a 1-degree amine, and it can be formed using Gabriel theramide synthesis. So if 1 degree, okay, no, you can only have SN2. And what SN2? Only alkyl halides. So if I'm using alkyl halide, that means only alkyl amines can be produced, not aromatic amines. So Gabriel theramide synthesis produces only 1-degree aliphatic amines, not even 1-degree aromatic. So that means that this option is also gone. So ultimately, if I need 1 degree, so I need a carbon over here. So that carbon will be, now this is a perfect 1 degree amine, aliphatic also, but this is giving me 7 carbons. I want 8 carbons. So let us draw the isomers of that 8 carbons. So it will be, the 1 CH3 will be ortho, meta, para. So how many isomers I'm having? 3. But can you think of any other structure also? Yes. If I take, now this is a beautiful question using amines knowledge also, using isomerism also, using geometrical and optical isomerism also. I'll tell you how. Once you are using 2 carbons over here, okay, let me not add hydrogen because I will be having an option of adding nitrogen. So if I add NH2 over here, still it is 1 degree amine having the same number of carbon atoms. If I use the same structure and form NH2 over here, still it is 1 degree amine. I hope everybody is clear with this now. So after these 3 structures, this can act as a 4th isomer. This can act as a 5th isomer, but not 5th. Why? Because if you have formed this structure, then this carbon is not a regular carbon. This becomes a chiral carbon. Why? Because 1 methyl, 1 NH2, 1 hydrogen and 1 phenyl. So this is a chiral carbon. So one will be dextro and one will be levo. So ultimately this will be the 5th isomer and this will be the 6th isomer, because question is asking us number of isomeric aromatic amines. So ultimately all these are, it should not be saying aromatic. Yes, this is also having benzene ring, but Gabriel thalamide synthesis can produce 1 degree aliphatic amine with nitrogen not directly having the benzene ring, because for nitrogen to have the benzene ring, aryl halide has to react, and aryl halide do not give SN reactions like alkyl halide because of partial double bond character. So using alkyl halide logic also, using amines logic also, so your answer becomes beautifully, how many isomers you are having? 6 beta, not 3. Black mystery. Acha, black mystery must be giving answer. Okay, in the previous question. Okay, moving to the next one. A very important question from the chapter of alcohol, which says Lucas test. This is Lucas reagent, anhydrous ZnCl2 in presence of HCl. Lucas reagent produces carbocation, and that carbocation is attacked by chlorine, and that chlorine gives you white turbidity. So that white turbidity is actually Lucas test. So that's Lucas test is given by all the alcohols which are capable of forming stable carbocations. Generally 3 degree carbocation is most stable out of 2 degree and 1 degree. Hence as per NCERT we say 3 degree alcohol gives Lucas test. But ultimately the logic is all the species that form a stable carbocation can give positive Lucas test. I hope everybody is buying with the fact. Now because this is 1 degree alcohol, so it will not give. Although the degree is good, but this OH gone and a carbocation is over will not be formed because this is connected with the electronegative group. So this carbon will not entertain carbocation, and hence although its degree is not 1 degree, but still it will not give Lucas test because carbocation is not stable. So this becomes the question for stability of carbocation. Plus over here will be stable because this will be resonance stabilized. So this can give. Plus over here is not stable, it is very stable because cyclopropyl gives a dancing resonance which is even more stable than a aromatic stabilized carbocation. So this can also give Lucas test because carbocation is more stable. Now this is benzylic carbocation, so obviously resonance stabilized, so this can also give Lucas test. Carbocation here will make the complete compound aromatic, so this can also give Lucas test because cyclic conjugation, and it is after that cyclic conjugation, the conjugation is done by how many pi clouds? 6 pi electrons, so this becomes a perfect aromatic system. Yes, this can't do because this will undergo tautomerization. On tautomerization, enol form gets stabilized in form of keto form, not enol form, so this can't give, it is unstable form. And yes, this also can easily give because this is in fact a 2 degree benzylic carbocation. So how many carbocations are stable which can Give positive Lucas test 1, 2, 3, 4, 5. So answer is 5. These are some very possible and probable questions, beta. Please revise them now. Again, the next question. So this is Wood's reaction. So Wood's reaction will form butane. It is saying propane. So no. This is Kolbe electrolysis. CO2 will be released. Radical will be coming over here. So chain termination, it will form an alkene. Yes, perfect. One more other product will be this radical can do chain termination with another radical also. So actually here cyclopropane can also be formed, but this will rather be a minor product. Why? Because it will have Baird strain. Rather alkene will be the major product. So a good question. That can also be produced. Yeah. Calcium and barium salt of carboxylic acid releases the corresponding carbonate. So barium carbonate is BaCO3. Once you remove BaCO3, whatever you are left behind, you draw the structure and it forms the carbonyl compound. So it forms a 5-membered cyclic ketone. This is just a 5-membered ring, not a ketone. So if there is a double bond O at the side, then it will be the right product. This is wrong product. So this is also incorrect. Alcoholic KOH produces Sidzev product, which is the most stable alkene. So this alkene will be most stable. It is forming a less substituted product. So this will not be the major product. So obviously my answer is option 2, a perfect question to revise very important reactions of organic chemistry. Nahi beta, Asif, I have specially made some questions. I mean, yes, we have been giving these questions in our mock test also. I have specially designed these questions. Why? Because with one PYQ, you can revise one concept. But with these PYQs, you can revise very lot of concepts. So this will help me to give you all the possible things which I can. That's why I have worked on the questions, made those questions, selected those questions which can give you not one single concept, but throw multiple concepts with you, because January attempt has done the same thing with us. Multiple chapters logic used in one question. So that's why the tagline, you can actually score 95 percentile if you study. I'm not asking to mug these answer of these questions. Try and be in sync with the concept I'm using with these questions. It is definitely going to help you. Now, a very basic question, a very logical question involving alcohols. So concentrated H plus can protonate this OH also, but this carbocation will be more stable. So first this OH will be gone and I will be having phenyl carbocation, because this carbocation will be easy, more stable, resonance stabilized. Now because this is a 5-membered ring, so sir, ring expansion can take place and carbocation will be coming here. So this 5-membered ring will be becoming a 6-membered ring. So I'm making that 6-membered ring over here, 6-membered ring after ring expansion. So because plus will be coming at the carbon which will be having OH, and ring is meeting at this carbon which is having 2 phenyl groups. Now, because positivity is here, so obviously we know that deprotonation, one more is very probable in this case, that this hydrogen will be gone by some base during deprotonation, and instead of alkene you can easily predict this carbonyl group, this carbonyl compound, which is double bonded O and a phenyl and a phenyl. And why I am telling you to predict, it is also logical to predict this, because this G is supposed to be reacting with lithium aluminum hydride. So who reacts with lithium aluminum hydride? My dear, carbonyl compounds are very famous compounds who undergo reduction using LiLH4 and forms the corresponding alcohol. So obviously this will be getting reduced and I will be forming the corresponding alcohol by LiAlH4. Now this alcohol is my H, and after formation of this alcohol it is again subjected to acid and heat, as in again dehydration. So this OH gone, producing carbocation over here. But this carbocation can be stabilized by, sir, now I will allow the phenyl group to get rearranged because this will make the carbocation resonance stabilized. So the phenyl shifting will bring one phenyl over here, another phenyl over here, and positivity over here. And after that, deprotonation. So this hydrogen will be given electron by a base, and after deprotonation, I'll be forming this alkene. A very beautiful question which is helping us to study lots of concepts from NCERT level of chemistry, but also helping us to accommodate and accumulate all those concepts in a one question. So this will be your product I. You can find its molar mass. Now that is your homework. If you find that molar mass, divide that molar mass by 3, and you have to report this as an integer type answer. And once you divide the molar mass by 3, you will be getting answer as 78. I hope everybody is clear with this. Moving to the next question of organic chemistry, which is, again, I mean, I've used this concept, but I'm just using this question to let you understand this, that if you have an ester, so first species of Grignard reagent will try to open up the ester. So this ester will be converted to O minus and whatever MgBr Grignard reagent we are having, but this carbonyl group will be introduced with a phenyl, and this will not stop reacting. This will react with one more molecule of Grignard reagent, and the carbonyl group will now turn into alcohol. This O minus and this C, again O minus, one phenyl it is introduced. Again, one phenyl it was having initially. So 2 phenyl, and that O minus and this O minus after hydrolysis will receive H from medium. So this will be your product. A very beautiful question, although this I have used in the previous slides as discussion, but for a mains level of question, such logic of NCERT are very important. This is how you make ester react to form a corresponding alcohol. Moving to the next question from, again, GOC, very important point, that who all compounds can show optical isomerism. Optically, obviously we know a chiral carbon. So obviously this is no chiral carbon, but this is a chiral carbon. Why? Because if you see this carbon, it is having one CH3 group, one hydrogen, although this is CH2. But that is not CH2, that is a double bonded carbon. So this carbon becomes a chiral carbon because it's an sp3 hybridized carbon. So yes, this is an optically active carbon. Similarly, alkenes with odd number of alkene are also optically active, because let's say this bond and this bond is in the plane, but this bond will be outside and inside the plane. So this molecule is also not symmetric. So alkenes, but not all alkenes. Alkenes with even number of, with even pi bond are optically active. Yes, if you had odd number of alkenes directly conjugated to each other, it will not be an optical stereocenter. A very famous example of an optical isomer. So who all are optically active? 2 and 3. So option 3 is your right answer. Many students leave this point considering it to be an advanced topic, but this much at least you should know, that alkenes having even number of pi bonds are optically active because they act as an optical stereocenter. Moving to the question from carbonyl compounds, aldol and kenizaro. So just one example of aldol, that too self aldol, because aldehydes have more affinity to be attacked by a nucleophile because they have less steric strain also, and they have more positivity than ketone. So obviously ketone tries to attack and they receives the attack. Now if this carbon attacks that particular carbon, you form a 7-membered ring, which is less stable, rather prefer a 5-membered ring. So instead of this carbon, I am asking this carbon to remove hydrogen and take the minus and form the carbon ion in presence of a base. Once this carbon ion attack this carbonyl group, the double bond O becomes OH. Let me count number of carbon for you. So this is 1, 2, 3, 4, 5. So you form a 5-membered ring. So I form a 5-membered ring, and the first member of the ring having the OH, and it is connected with the 5th member, which is actually connected with C double bonded O and a CH3. Now this is after this reaction, what happens for an aldol? So carbonyl group, next carbon is alpha, next carbon is beta. Alpha beta dehydration takes place and it gives rise to a alpha beta unsaturated carbonyl group. So this becomes your alpha beta unsaturated carbonyl group, which is clearly option A, a very good and healthy example for aldol condensation. More better example because this is self intramolecular aldol condensation. Moving to the question from biomolecules. Now I have been giving you this list of essential and non-essential amino acid. This list I'm giving you again because once you remember this list of essential and non-essential 20 alpha amino acids, you will definitely score one question like this. For example, serine, once you know it is an alcohol, so this is also saying alcohol. Once you know alanine is a neutral alpha amino acid, so both statements are correct. But such questions, such easy questions can only be easy for you once you go through these 2 slides. So again, once we are done with this lecture, please go through WhatsApp channel, download these notes and reattempt these questions. Moving to directly inorganic side of chemistry, which obviously because we have spent so much of time in the live and the inorganic side of chemistry, what is asked, the basic points I'm discussing over here. For a D block and complex coordination compounds, you should know that which of the following statements are correct. For an F block, for lanthanoids, we definitely know all lanthanoids forms compounds in +3 oxidation state, which becomes their family oxidation state. Although +4 and +3 is also fine, but only found in nature if they have some special electronic configuration stability. Like for example, cerium, after lanthanum what comes is cerium. So cerium has electronic configuration of 6s2, 5d1 and 4f1. So cerium in +4 oxidation state is having actually inert configuration. Therefore cerium +4 is known to be existing in nature, but this also be very this also should be kept in your mind that such stable oxidation state will not allow that particular oxidation state to become more stable. It will just allow the lanthanoid to at least exist in that form. Still, that form also will have a tendency to come back to the group oxidation state. So cerium +4 will exist in nature because its configuration is very stable, but still in nature whatever compounds of cerium exist, they will predominantly try to come in what oxidation state? The family oxidation state, which is +3. So cerium +4 existing in nature will try to reduce itself because all the lanthanoids wants to they are in love of getting to their group oxidation state of the family oxidation state, which is +3. So cerium +4 to +3 will reduce itself and will oxidize other, and definitely it can oxidize water also, but it is saying cerium cannot oxidize water, therefore it is incorrect. Lanthanoids only exhibit +3, we have already seen. Yes, +3 is their most stable state, but if at all it is having some strong or stable electronic configuration in +2 or +4, that they may exist, but they will again try to come back to +3. But saying that it only exhibit +3 is wrong. Europium +2, all lanthanoids actually form +3 ions only commonly. Yes, europium also can form +2 because again it has half-filled configuration in +2, but also again it also tries to come in +3 oxidation state. So it is saying commonly existent. Yeah, this is definitely correct, but yes, its +2 can also be found. Lanthanum in +2 is more known, the +3 is most famous. So obviously here only option 3 is correct. So playing with theory, but very important and logical question. The next question says, which of the following has 0 crystal field stabilization energy? So which has 0? So I'm directly giving you the logics. Manganese, if you just consider manganese, manganese is 4s2 3d5. Manganese in +2 state has just 3d5. Now, if you have a splitting and the splitting is done by water, which is a weak field ligand, that means the splitting is very less. That means the fifth electron is filled how much? How? 1, 2, 3. And the fourth and fifth electron goes to the EG site. Why? Because the splitting is very less, because water is a weak field ligand. So we should definitely know that for an octahedral complex, what is the crystal field splitting value? Sir, these two get higher energy with respect to the Berry center, which is considered as the zero, as the average, the zero state. They are having higher energy and they have taken energy from whom? From these three. So this will be 3 by 5 times of delta naught, and this is 2 by 5 times of delta naught. If I'm saying 0 is the Berry center, so 3 by 5 is 0.6. So this is plus 0.6 times of delta naught, and these are minus 0.4 times of delta naught. These contribution are done by the electrons. So here 3 electrons will have contribution of -4. So 3 into 0.4 with a negative sign is -1.2. But 2 with a contribution of 0.6. So 2 with a contribution of 0.6 with a positive sign above Berry center will have a plus 1.2 contribution. So ultimately its crystal field stabilization energy will be 0. So this guy will have a 0 crystal field stabilization energy. A very important logic also, a very important point also. Now, basic of D block element, that chromium and copper have stable electronic configuration of 3d5 and 4s1. Assertion is correct. Electrons are filled in increasing energy. Yes, electrons are always filled in as per n plus L half power rule. This is also correct. But why electronic configuration of chromium and copper is that? Because of stable half filled and fully filled. So both statements are correct, but this explanation is not valid for that assertion. So obviously a very good theoretical question also, a better question to remember also. So both are true, but yes, not an explanation. Here you can clearly find number of unpaired electrons. If you find those number of unpaired electrons, let me help you with any one of them. Like for vanadium, this is Shakti Walker as in 4s2 3d3. Vanadium +4. 4s electrons will be gone first because it is outermost. After that, 2 more I need. So 3d3 becomes 3d1. So how many unpaired electrons? This has 1. So those who has more number of unpaired electron will have higher magnetic moment. What is the formula of magnetic moment? Under root of unpaired electrons plus unpaired electrons plus 2 unit is Bohr magneton. So obviously you can categorize and segregate which is higher, which is lower. Borazine, this is a block chemistry logic which has nitrogen and boron in alternate position. So nitrogen and boron in alternate position, and every species having one hydrogen. The famous inorganic benzene is this. Obviously it is single bonded, but how it is, why it is called a benzene? Because you should know this is a chemical bonding logic, that nitrogen having lone pair of electron makes it a Lewis base. Boron having deficiency of electron and empty orbital makes it a Lewis acid. So this back bonding or this bonding makes the molecule look like a benzene molecule, and in this benzene molecule you can definitely find number of sigma and pi cloud. Pi cloud is obviously 3. If you calculate sigma cloud is 15, so your answer will be 12 and 15, so your answer will be 15. A very good example, a very good chemical bonding logic also. Moving to my last question, again from chemical bonding. Here we are supposed to calculate how many planar species I have. Now BF3 everybody knows is planar. Nitrogen, because it is having lone pair, so this is pyramidal, so it is not planar. Iodine, having that extra electron, will have iodine, make iodine as iodine minus, so it is iodine is forming 4 bonds with chlorine, but it will be having how many lone pair? 2 lone pair. So those 2 lone pair will be upside and downside, hence this octahedral geometry will allow the chlorine to be in same plane, and hence this will also be square planar, but yes, hybridization will be sp3d2, but the lone pair will be opposite, hence this will also be planar. And similarly xcf4, just like ICl4 minus, will also be planar. SF4 definitely, because of presence of lone pair, it will be having a seesaw shape, so it will also not be planar, so because of the presence of lone pair. Yes, boron compounds, although it is F or OH, because boron is having 3 electrons with empty orbital, so this is also trigonal planar, so this is also planar. Phosphorus is definitely a species with 5 electrons in its valence shell, so this OH, yes, one hydrogen will be reducing, but this will also make this phosphorus tetrahedral. So because it is tetrahedral, so not planar. SO3 again, because of presence of empty d orbital, can also become planar. So this is also a planar molecule. Again, mixing it with D block chemistry, if you go down the group, then platinum, palladium, if down the group you go, the crystal field stabilization splitting increases, because metal, all the D block cations which are having high Z effective, they themselves do very high splitting, and therefore when you have 4 coordination number with high splitting, you tend to form a square planar complex rather than a tetrahedral. So platinum, even if whatever weak field ligand you take, if have 4 ligands, then it rather prefers to have a square planar geometry than tetrahedral. And yes, nickel will definitely have a tetrahedral geometry. So because this is tetrahedral, so this is not planar, but platinum complex will be planar. So how many planar geometries I'm having? 6. So your answer will be definitely 6. This finishes our discussion for the questions that we have selected for you. Your maths class will be going right now, so all the very best for that. Please revise these concepts in order to be mastering your chemistry for JEE. Best of luck. We'll be meeting soon.